got the plastic coming off there right now. Yeah. Well, no, it's got to come off the trailer. They don't lift it off until you paint it come off.
exactly like that.
We're going to look once again at a video we showed yesterday of the Ares 1X vehicle being rolled out to the launch pad from the vehicle assembly building to pad 39B. Activity which began late in the evening in preparation for a first motion which began shortly after 1:30 in the morning. This is inside High Bay 3 of the vehicle assembly building. Adjacent to the high bay where Space Shuttle Atlantis was stacked and prepared for its launch. We're looking up the entire 327-foot stack. And here we can see first motion, the vehicle beginning to pull away from the access platforms. This is the tallest stack since the Saturn V to roll out of the vehicle assembly building.
I think it's like 25 by 50, roughly. Yeah.
Good afternoon, everyone. This is our news conference for the conclusion of the Ares 1X Flight Test Readiness Review, which was held this afternoon at the Kennedy Space Center. And here to update us on that review and our launch countdown status for the Ares 1X on Tuesday is Doug Cook, the Associate Administrator for the Exploration Systems Mission Directorate, Bob S., the Ares 1X Mission Manager, and Ed Mango, the Ares 1X Launch Director. And we'll begin first with Doug Cook, the Associate Administrator for the Exploration Systems Mission Directorate. Doug?
Thank you. I have to say that it's a privilege for me, as I told the team this afternoon, to be the chairing the Flight Test Readiness Review for Ares 1X. This team has done a tremendous job in getting to this point in the flow. They started with an authority to proceed 3 years ago, just a little over 3 years ago, and have taught themselves what it takes to design and build a vehicle and get it ready to fly. And they within the last few weeks have worked through a mountain of work and closeouts and final technical issues and that sort of thing to get to today, where we reviewed all that work, the issues that they worked most recently, and we got to a point where they have gotten to a point where there are really no technical issues. They've closed out their paperwork. To this point, all they've got is the forward work to get to the Tuesday launch. So I'm very proud of the team. The team is made up of people from multiple centers at NASA, an industry team, the technical, what we call technical authorities, which are the people who contribute to the team by making sure that we do everything properly. The safety and mission assurance folks, the engineering and technical authorities that make sure that we've covered all our bases. So at this point, it's apparent that they have, and it was a unanimous decision by the board today that we passed this flight test and readiness review. So this team, representing some of the best of NASA, I believe, was ready to go fly.
Thank you, Doug. And now to Bob S., the Ares 1X Mission Manager. Bob?
Good, thank you. As Doug said, we had a pretty comprehensive review all day today and included members from all across the agency that was not part of our team, but also outside of our team, just to make sure that we're really doing what we think we're going to do and we're ready to go fly. It was very, very clean. There was no open actions or open items to be worked. And over the last 3 years, we've been working closer and closer to this day and getting the flight test readiness review for the agency. And along the way, we found a lot of technical challenges, and we've solved those. And we keep getting closer and closer. Today was the culmination from our review cycle that we convinced ourselves, and now we convinced the agency management that the vehicle is clean and there's no open issues. And we were successful, and it's very good for us to work that way. Over the weekend, we'll continue doing some work on the vehicle, and Ed will talk more about that. But so far, we're good to fly next week, and it's really been a great effort by the whole team across the agency.
Thank you, Bob. And now to Ed Mango, the Ares 1X Launch Director. Ed?
Yeah, good afternoon, and thank you. See, it's great to be part of a team that can put a rocket together in the time it took. Also, it's great to be part of a team that is really spread across multiple contractors and multiple centers. So the team is ready to go fly. The vehicle is actually ready to go fly. It's a very unique vehicle. It's a test vehicle, but in the same time, it's also one that we got to be successful on our launch. So we're treating it just like any other launch vehicle here that we're trying to go lift off with. So the team is ready. We had our pre-test briefing for launch countdown this afternoon, and that went without any problems. As Bob mentioned, we're in very good shape in terms of the hardware and in paper. Right now, we're not working anything outside of what's in front of us. And so as we work through the next few days, we will get all that work done and be ready to go fly on Tuesday. Since we did an integrated test basically yesterday, and during that test we checked out a number of the comm systems, a number of the capabilities to talk to the vehicle, as well as we did a hot fire of our HPU system, and all that worked extremely well. The hardware is in great shape, and it's a credit to all the folks throughout all the different centers and all the contractors to bring hardware together and have it work so well when you first put it together. One of the things we're trying to do with the Ares 1X mission is also to get to this point where we do as much as we can in the VAB prior to rolling out to the pad. And Ares 1X proved that very well when we rolled out just the other day. The only things we had left to do was prove our RF system would work on the pad, do our integrated testing, and then also basically do ordnance, which is what's left to be done. Ordnance will be done on Sunday, and then we'll be ready to go fly on, start countdown on Tuesday very early in the morning. And that's all I had.
All right, thank you, Ed. We're ready now to take questions. Please give your name and affiliation when the microphone comes to you, and we'll start over here on the left with Bill.
Bill Harder with the CBS News. Mr. Mango, can you give us a little weather update and what your options are? Do you have 3 days on the range, or is it 2? And if you didn't get off next week, are you good to stay at the pad until, I don't know, after shuttle and after all the stuff coming up in November? What are your long-range options if you don't get off? Thanks.
Let's see, weather is always a challenge, and next week will be no different. We have weather constraints for Ares 1X that are different than you've seen in other vehicles around here because it's a 300-foot tall rocket, and so we have a number of requirements. It's also a first-time vehicle, so we have a number of weather requirements we'll be looking at very carefully. Right now, the weather, and our weather officer will be telling us more about that on Sunday and Monday, but right now the weather does look challenging. I'd say it's I think her forecast today was 60% no-go, but again, we're 5 days out, and a lot can change in those 5 days, and that's what we're looking forward to. And so the team will be working through the weather as we get closer, and when the vehicle's in great shape, the only thing we'll be working is weather, so that'll be good. In terms of launch opportunities, we have 2 of them right now on the range, the 27th and 28th, both from 8 a.m. till 12 noon, 4-hour launch window. We are working to see if we can't get other opportunities on the range, and we'll see how that goes over the next few days. In terms of what happens after this window, after this particular window, we'll be working with Bob and the rest of the vehicle team to figure out how we can leave the vehicle at the pad if at all possible, which is what we like to go do, and then see what we need to do in order to keep the vehicle in a place where it can sit there until we're ready to go try to fly again. And yet, the month of November is very difficult in the range in terms of trying to get space, but we want to be ready as soon as an opportunity opens up to jump on the range at the time and try to go fly then.
Follow on the kind of weather related, can you give us any numbers on what kind of loads you guys saw during rollout and how your VSS has worked at the pad, what sort of stuff you've seen at the pad since you've been there? Thanks.
As far as rollout, Bill, we designed for rollout some pretty conservative estimates purposely. So in the case the wind would pick up during the rollout, and in case we got something which we call a wind-induced oscillation, in case the vehicle would shed vortices and cause it to move back and forth like you'd see a telephone pole or something else. We designed for that case not only for rollout but also for rollback. We have control over rollout. We were concerned if we're at the pad and for some reason we had to come back because of weather or for a hurricane, in our previous launch that we were going to fly in the summertime, that we wouldn't have as much notice to go roll back. We have to deal with higher winds. So we were able to design the vehicle and to analyze the vehicle to some pretty hefty wind cases. And what we saw Tuesday night or Monday night, Tuesday morning, was pretty benign winds. I mean, there were 15, 20 knot winds. We have a lot more capability in that vehicle than that, and we didn't see that wind-induced oscillation effect, and that is the major contributor to the loads on the F-skirt. So because of that, the actual values that we were looking at were probably 10% of what we could have handled, if not more. So we were in great shape for rolling out. It wasn't even close to anything that causes concern. I don't have any info on the loads in the pad unless you do. I do know the VSS is doing its job, and we're on the pad. The vehicle is not moving at all, and either VSS springs aren't moving either. So it's pretty tight.
James Dean from Florida Today. Question and follow-up, if I may, for Mr. Cook. Could you offer your reaction to the Augustine Committee's findings with respect to Ares 1 and the questions it raised about whether or not it makes sense to continue with the development of that rocket?
Well, we are happy that the report is released, and we have that to work with. We are assessing our options. We at this point basically they have provided their observations, and we will be working to develop our understanding of the options and working with the administration and other stakeholders as we work toward decisions. No decisions have been made at this point. So it's really premature to comment on that aspect of it.
Can any of you speak to the relevance of the 1X flight test for the program, whether or not the decision is made to continue with Ares 1?
We believe that, and actually feel very strongly that this test is very important for a number of reasons. Actually, by getting to this point, this team has taught itself and is a pathfinder for what we do in human spaceflight and developing the next vehicles. We haven't done this with a launch vehicle since the space shuttle, which was developed in the beginning in the early 70s, and so we're learning the process of designing and building a vehicle, learning lessons learned, good and mostly good actually in this case, but some things that we would have done differently or would do differently in the future. So even getting to this point today, this team has learned about getting a vehicle designed and ready to launch, and it's really an inspiring point to be at, and the vehicle there sits out on the pad ready to go. When we get to flight, the data is important to us, regardless of what comes next. We will learn a significant amount about the guidance aspects. We've developed a guidance system. It will fly a first stage trajectory that we'll learn from. We have over 700 measurements on board to get information on aerodynamics and aeroacoustics. We've learned through this development, through wind tunnel tests and computer programs, that the loads induced by some of these environments are very significant. And so we'll learn from the data that we get back to validate our models, some of which are really kind of being used for the first time. And so there's a significant amount of information that we get there that may simplify further work on design beyond where we are right now. We'll also test out the parachute system that is designed for the solid rocket boosters for the next vehicle, and we'll get through the entire end-to-end process from design concept through flying, through getting the data back and processing it on a vehicle that's a first-time vehicle. So it's very significant data that is going to be very instructive to us since we haven't done this in a long time.
Marcia?
Marcia Dunn, Associated Press. My first question for Mr. Cook. Do you feel that it's unfortunate timing that the test flight is occurring so soon after the report, the Augustine report came out, that wasn't particularly flattering toward the Ares? And has that put a cloud over the entire test flight in your mind?
I would tell you that observing this team today, there's no clouds over them except for the weather next week, possibly. They're totally committed and they're living on adrenaline almost. But it's a very tight team. They're doing a great job. The timing is what it is, but the test is significant, and it's one that we fully back.
Thank you. And for Mr. S., how many days, weeks, months, I have no idea, will you be looking at all this data, all these 700 sensors? How much time to crunch all that before you have a good handle on how the flight really went?
Yeah, it's really more months than anything. So we'll fly ideally next Tuesday. As you said, there's over 700 sensors on board. We'll get a feedback within the first few days of generally how the vehicle flew, what direction it went, and specifics like that. But as we get more and more detail, it's a huge amount of data. 700 sensors. They're all sampled, many times a second. It's reams and reams of data that will take, at best, months to go through and understand really if the vehicle behaved the way that we thought it would. But also to take that data and to use it for its real purpose is to update all the computer models that we have. It is something that we'll be working for the next couple of years to go do. It's a very long process. This vehicle is a flying wind tunnel model, is one way to say it. We have a lot of sensors on this vehicle that match sensors we've had on wind tunnel models, that also match locations on computer models. So this allows us to put those three together, understand how much conservatism we have in some areas, some things we may have missed, and really update our computer models really is the whole goal for whatever vehicle we end up flying. But that's a long process and was meant to be a long process. And that was the motivation for flying this flight as early as we possibly can. So in 2009, if we can get some early data, that's early enough for the Ares Orion designers to use that data into their design. If you waited a couple of years later, you can get some data, but it's really tough to change your design at that part, or it's very expensive.
Jay?
Jay Barbary with NBC. A couple of days ago, General Les Lyles, who is arguably the best rocket engineer and rocket scientist that we have in this country, came out for Ares 1. As you know, he was a father of Delta II, which has highly been successful. And he said clearly that we should continue with Ares 1 because we could not get commercial ready to do anything but go in a low Earth orbit, and he was very complimentary to it. As a panel member, he came out with it. Now, if you have an expected good test flight next week, I understand you've spent up to this point of the Constellation money $400 billion to get to where we are now, and you need another $300 billion to finish Ares 1 to get it ready to fly astronauts into orbit. If you have a good test flight, my question is, am I correct on those figures? And number two, how long do you think it would take you to get Ares 1 ready?
Actually, the numbers for this test, if you're asking about this test, you're talking about the overall.
Mr. Cook, I'm asking about how much has been spent on the Ares part of Constellation to this point. I understand it's $400 billion, and then I was told we need $300 billion more to finish the project. In other words, what is it going to cost America to finish Ares 1?
No, the numbers are, I don't have the exact numbers on what we've spent, but it's more on the order of 6 to 8 billion.
On Ares alone? Because you've spent 9, I understand, on Constellation.
That's probably the right number.
But I'm talking about on Ares, not counting.
I'm not sure of that number. We'd have to get
okay.
that for you. And you know, and by our estimates, in terms of available budget that we've had, we had estimates for 2015 getting to that point, and it was the number for and it's not just Ares, it's for Constellation was on the order of 36 billion at that point. So those are the numbers that we've had in our cost models and have reported out on. Once again, I think that all information that we have, including the Augustine report and the work that we do in understanding those options, will all factor into the decisions that will come down the road.
You know, I think I said 400 billion when I meant 4 billion
Okay.
and 3 billion. So you're talking 3 billion 6 now. Is that what you did? What did you say?
For Constellation, it was our number was is on the order of 36 billion through 2015.
Okay, thank you, sir.
I believe that's about right.
Further questions? Yes, in the back here.
Hi, Clara Moskowitz with Space.com, and this is a question for Mr. Mango, I think. What do the teams have to do between now and Tuesday to prepare for launch?
Okay, well, the teams, starting tomorrow, we have our final simulation that we'll be doing not only with the prime launch team, but also with our launch support team, and as well as our launch authority team. And it'll be the third time that those three entities all get together for their final simulation. That'll be all day tomorrow. And then on Sunday, we do final ordnance connections. The ordnance has been on the vehicle since we put it on in the VAV, and what we do on Sunday is basically do our connects. And so we'll be doing that throughout Sunday. Monday is pretty much we're trying to make that as much as an off day as possible for the team so they can rest up and be able to go get into countdown. Countdown starts about 1 in the morning on Tuesday morning, and it's a 7-hour countdown. So hopefully Monday is a day off for everybody as much as possible, and then we come in at 0100 on Monday or Tuesday and try to go fly.
Dan?
Yes, Dan Billow from WESH. A couple of questions, if I may. Can you quantify the risk of a loss of vehicle? Do you have a number on that and you know, this being a first launch, of course, of a new vehicle, would you consider it more risky than because it's the first?
All right, first answer is no. We don't have a number assigned to this one, and probably for the reason that you said. It's a first-time vehicle. It's also a hybrid, as you know, of taking some new hardware with Atlas V avionics with some Shuttle Heritage hardware and putting those together. Makes it very unique to go do that. We have talked a lot about, you know, success and criteria, but we don't have a probability to give you for this flight.
Okay, but you don't think it's more risky than most launches because it's a first vehicle?
Yes, we do. It definitely will be riskier than a shuttle flight. You know, because it's a first-time vehicle, first kind of configuration. Like I said, we're putting together different parts from different aerospace systems into one, and so there is risk with this flight, and it's a test flight, and that's part of the reason that we're doing this, just to make sure it works. And so we can't guarantee success next week. We've done a lot of work to try and ensure it, but yeah, there's definitely risk in this flight.
And just one more question, if I may. What about the stakes for the space agency and the Constellation program? Do you guys feel like, you know, there's a lot riding on this and it's on your shoulders?
I don't. We don't put. I wouldn't say that we feel exactly what you said. You know, obviously it's a very visible flight. It's a test flight, though, and it's possible that you learn things in tests and things don't work right at times. So the expectations are that we think the team has covered all the bases on getting this vehicle launched and worked all the technical issues to get there. But certainly there are risks with a test flight. It's not as certain as a vehicle that's been flown a number of times. Probabilities get better as you fly a vehicle and learn from it, from what you've done. So we realize that it's a riskier flight. You can have failures on tests, but that's why you go test. You want to learn. It's a new vehicle concept, so we want to learn about it. And so I wouldn't say that we're looking at it from that standpoint. We are looking to get data from it.
Bill, a follow-up?
Just a couple of quick ones, if I can, kind of nuts and bolts stuff. For Ed Mingo on the window, how much do you really just need, like 5 minutes in there somewhere to get off? I'm trying to understand. I know it's a short flight, obviously, but what do you need weather-wise, visibility-wise, all of that, because it's a test flight? You know, just trying to get a sense of how to put the big window into perspective with the short flight direction.
Let's see, from ability to go fly and get good data, our requirements from a weather standpoint are really follow a number of range requirements to make sure that they can see the vehicle, to make sure that if there is any issue they can take their action. The rest of the requirements are really there to grab the right amount of data. So we need a pretty clear sky, really. We also need winds that are, right now our requirements for winds are 20 knots really from any direction at liftoff on the launch pad. And again, the reason for that is because we're trying to validate some of the models, and the models have been anchored in some wind tunnel data as well as some analysis that says 20 knots will give us margin to make sure that we don't get into trouble when we first lift off. So we have to put all those together. Now, how long do we need to have a hole in the sky, if you want to put it that way? Probably about 10 minutes. But again, it depends on typical, if rain's coming in, how soon before the rain's going to get there. If there's winds, when are the winds going to die down? We're going to put all that into the bucket together and then try to figure out if we can find a 10 or 15 minute window in that 4-hour launch window.
Thanks. And one for Bob. You were talking earlier in the week, I think during rollover, we were talking about program test inputs going uphill with moving the nozzle a little bit to see how the vehicle responds. Can you go over that a little bit? I was unclear on the timing of when you guys were going to do that kind of stuff.
Yeah, I go over it in a bigger sense, and maybe I can just give you a sheet that kind of outlines what it is and when. We have about 3 different times during a flight where we're going to put in these program test inputs, and what that is we're purposely going to induce some action in the rocket nozzle, and therefore get some reaction in the vehicle. And by knowing how much input we put to the nozzle and measuring what we get from the vehicle, we can understand a little bit better about the vehicle itself and how it flies. So soon after we clear the tower, we gave a very small input, it's a few tenths of a degree, just to make, in that regime. So it's about regimes and Mach numbers in that area. So before that point, we'll have a really small, couple tenths of a degree input. It's not much, you won't see it. And then the max dynamic pressure area, which is the hardest region to fly through, we'll keep it clean. We won't mess with that, so to speak. And after that, about 70 or 80 seconds, we'll put in another input of about a half a degree, something around that range. And again, we'll do the same thing. You basically move it one way, move it to center, move it the other way, move it back. And that sinusoidal input should make the vehicle move a little bit, and we'll pick that up on our sensors. And we'll see it probably during our post-flight analysis, a couple of weeks later. It probably won't be visible to you as you're watching it on TV. And there's one other region in there, I forget the exact time, but again, it's later in the trajectory. The closer we are to the maximum dynamic pressure area, the smaller the input is, just to keep the loads in the rocket in a well-behaved area. And as we get closer to the burnout, closer to 2 minutes, we can put some bigger inputs on there. But I can get you the exact numbers of the deflection and the time and feed it through the PAO folks.
James Dean from
I'm
sorry.
Go ahead.
James Dean from Florida today. Just a couple more questions on the risk side. Has there been a final assessment on the risk to Pad A?
Yes, there has been. There are calculations that have been made, and it's been checked by the 45th Space Wing, and it's been checked by our engineering organizations within NASA, and the requirement is like 10 to the minus 1 and 10 to the minus
1 in 1,000.
1 in 1,000. That's the requirement, and we're actually about an order of magnitude better than that. So that's really been that in my view, that was a call by Space Operations Mission Directorate and the shuttle program. They have bought off on that risk, and actually, because of the requirement that we actually have, we're not writing a waiver for that case. So they feel like it's within acceptable risk.
I was just wondering if, I guess from a technical side, was there any special mitigation needed to earn the spot on to get the range on board to make sure they're confident it's going to be a safe?
The interaction with the range started 3 years ago. So in the beginning, we tell them what we want to go do and how we want to go fly this vehicle, and they try to understand really what it's all about. And it's a first-time vehicle, it's very long, skinny, and all those things factor into it. We have to justify first to ourselves and then to the range why the vehicle is going to hold together. We've done sufficient loads analysis to understand that we're actually going to fly in the regime. The range is all about protecting the public and other assets. And so along with that, we have to demonstrate that the flight termination system we have on board, which is a linear shaped charge all the way down our booster, and it's longer than shuttles. For ours goes through the bottom segment of the aft skirt. We have to prove to them that flight termination system will work during the environments that we'll see during Ares 1X. And it was very much a mutual beneficial relationship. We gave them data, and they gave us feedback, and we worked it around the last couple of years. In the last few months, we just had to do our finishing touches. We got our final load set, we did our final analysis, and we decided to go off and test some of the components just to make sure. So there's a receiver, a decoder that receives signals from the range. We did some vibration testing on that. And we also tested some of our batteries. Those were two areas that were above what they would typically see for shuttle. And just to convince ourselves first and then the range that we were good, we completed those tests. So the range is all clear. They gave us their go today. All issues have been resolved with them. So we're good to go with them.
Marcia, follow-up.
Marcia Dunn, Associated Press, with two follow-ups. If the requirement is 1 in 1,000 for impact to Pad A, what was the calculated? You said orders of magnitude, but do you have a number?
It was 1 in 10,000, roughly.
1 in 10,000? Oh.
Yeah, about 10 times better than the requirement, roughly.
Okay, great, thank you. And I'm curious, why is the test flight have only 4 segments to the booster instead of 5? Could you just explain to me?
Sure. Our goal when we put this flight together 3 years ago was to get this kind of data as early as we possibly could. And so time matters when you're an engineer putting together the finishing touches on your system for Ares and for Orion. The 5-segment booster, you may have seen, we just did its first ground test a month or so ago. And to get the first flight-ready version of that would still be far in the future. We wouldn't fly till next year or the year after. And we had a shuttle booster that was available to us with 4 segments. So we decided with a 4-segment booster, and by changing the weight of Ares, so our vehicle is 1.8 million pound. The Ares Orion rocket's close to over 2 million pounds. So we can change the weight, and there was enough thrust and propulsion for us to take off and fly the same dynamic pressure profile that Ares 1 does, up to about Mach 4. And that's just the sweet spot from flight testing, if you will. That's the part you really want to test. So we'll end up at a different point in the sky than Ares 1. We're a little lower when we finally do our staging. But all the good data is really in that area from liftoff to Mach 4. And so early, we could do that test this year in 2009 by using that concept.
When do you expect to reach the Mach 4 point in the flight?
Yeah, right about staging. So when we
Okay,
burn out the
right.
booster, about 2 minutes,
Okay.
122 seconds, that will be right about Mach 4 and a half.
Okay, all right, thank you.
I guess I'd like to add just a little bit to what Bob said. The vehicle Ares 1X was a concept that was developed in 2000, basically starting in 2005, and went into development in 2006, and so it's not exactly what we would end up flying, but what's important is we have computer models of how it should fly based on the exact configuration that Ares 1X is. So we have computer models that reflect how it should fly. In terms, another thing that we'll learn about is thrust oscillation, which has been a technical issue that we've worked, and it's not exactly this. The oscillation is not exactly what it would be for a 5-segment booster, but we can model the 4-segment booster, and we can check our models, and that's one of the most important things that we'll get from this data, is that we do have wind tunnel data, and we do have models that have been run to duplicate or to actually model at this exact configuration. And so when we compare against that, it actually validates models for a configuration that is very close, relatively close to the evolved design. So the important aspect is we check our models and validate them. Dan?
Yes, Dan Billow again. Can you, any one of you, just kind of give me an idea on how it will look, what we should expect? Is it something that, more like a weather rocket that'll get out of here in a hurry? I mean, how's it just going to look, do you think?
Sure, I'd answer that one. It's going to look pretty spectacular, is the way I would say it. This is a little bit higher thrust-to-weight ratio than the shuttle, so as far as how you'll see it clear the pad, it'll be a little bit faster. I think from it being long and thin and slender, it'll optically look very strange coming across. There is the equivalent of a roll program. We do roll the vehicle after we clear the pad. It's not for the reason the shuttle does it. It is a reason for us to get our sensors oriented in the right wind axis that we want to. And so you'll see the whole vehicle turn around about itself, and then just kind of head due east. And so lately, all the shuttle missions have been going up to the space station. So we have a northeast trajectory. We're going due east, which we haven't done for a long time. And so you'll be able to see from a different vantage point this long, slender vehicle going across. But I think it'll move pretty quickly.
And it is a flight of the first stage. So once the separation occurs, that's really the end of the launch trajectory, right? It separates the upper stage off. The upper stage is a simulator, and it basically goes in the water, and the booster is recovered as parachutes back. So it's obviously a I guess you'd say a suborbital flight.
Right, and
We'll add that, on the shuttle flight, you have the main engine start, and they start for about, they start at 6 seconds, so you got your full up thrust at 3 seconds, so you have 3 seconds of steam that's coming out. In this case, you're not going to have any of that. You won't have very much at all until T0, and then it'll be just like the SRB ignition we have on shuttle, only in one SRB, and it'll get up and go a little bit faster than what shuttle does.
And how do you think the staging would look? That should be within visual range, and you'll be able to see that pretty clearly with the unaided eye?
Not exactly sure. We'll stage about 130,000 feet for this one. That's pretty close to shuttle as far as altitude. But we're a little further downrange when we do that. So as far as, I think you'll be able to see something happen in the sky, two white dots instead of one white dot. But I think it's going to be very clear. The camera should pick it up pretty clearly, assuming we have good weather next week. If we have any cloud cover, it's going to be really tough to see it.
Jay Barbary with NBC again. So we're going to have instant ignition of the solid rocket, and we're going to have instant liftoff, or is there any kind of delay at all? None at all. It's instant. It goes. And it'll reach Mach 4, which is what, a little better than 2,700 miles per hour and 130,000 feet up. And it'll go due east, so we should see it traveling faster than the shuttle travels, of course. So when you say 0, it's boom and gone.
That's correct.
Okay, thank you.
Bill, a follow-up?
A couple of quick ones from me. Is the sound, first of all, is the sound suppression system the same? I know acoustics off the pad are of interest to you guys. Is it the same water deluge system and bags that's used for shuttle?
Yep, yes, it is. In fact, what we did this time was we don't have an SRB in the other hole, so we've designed to add more bags in that area so that you don't have any kind of overpressure going down through the hole and coming up the other side. So it is a slightly different design, but it's the same basic idea for sound suppression.
And for Bob, just to follow one of Marcia's earlier questions, I know it's going to take weeks and a long time to really go through all the data, but what do you expect to know on the day of launch?
On the day of launch, we'll come here and tell you, a press conference about an hour or 2 hours after flight. And from then, we'll be able to tell you if it really flew due east, whether we've had the separation event, parachute deployment, all the recovery part, we should have a pretty good feel for, and a lot of it's going to be visually tracked. Probably not much else. There's a lot of data coming back, and just what we see real time on our screens basically is what we're going to be able to jot down. Probably a day or so after that, when we really can look at the data, we'll get a better feel for how the vehicle really flew. We have built into our plan a 30, 60, and 90-day report when we come back and tell the agency and the public what we learned from the flight. So the first one in 30 days was probably only about a couple of weeks at most worth of work. Once we fly and when the booster recovers in the ocean, and inside that booster is our data recorder, and we also have all the data telemetry to the ground real time. And what we do after we get it all back is we put it all together and we call best source. So we'll figure out for all the different channels of the sensors, all 700 of them, what's the best source data, and we'll synthesize the best time history of all the data. That takes a couple of weeks after the flight. And from that, we'll turn it over to the engineers to go back and look at it in more detail. So our 30-day report is really about a 2-week effort of looking through some of that data. And then the 60-day, we'll have a much better feel for what we learned from all these different sensors. So flight day is not about the sensors, it's about the way the vehicle dynamics. And then the 30, 60, 90-day report talk more about the sensors that we saw.
This might sound a little silly, but back in 1959, when they launched the first solid rocket from here, which was the Polaris, they put the same destruct package on it as they'd been putting on the kerosene fuel rockets. So it took off, and as it was going up, it went awry, and it hit the RSO hit the button, essentially blew the 2 stages apart. The second stage came back down, fell close to us, the press that was underneath almost watching it. And the first stage went all the way into the Banana River behind the Hitchin Post Trailer Park. And we changed the name of it from IRBM to IBRM in the Banana River missile. But anyway, I assume that you guys have the correct destruct package and everything if this should go towards Titusville or something, that you can get rid of it.
We have a better one than the shuttle. And so it's exactly the same as the shuttle. And shuttle has a linear shaped charge on the top 3 fuel segments. And we've added a length to that, so it extends all the way down to the bottom part where the aft skirt is. So we know from Challenger that we can separate that booster if we need to. And now it's a bigger, so I think it's going to be much less risk in that way.
And I would also say that way back, we're also learning how to go do range safety destruct systems. Over those 40 years or so, the #1 job of the range and any customer, and in this case Ares 1X on the range, is to make sure that we're providing safety to the public. And so between us and the range, there's nil chance that this vehicle is going to go anywhere where the range can't take care of the vehicle if it needs to.
Could you just confirm again the mission cost, total mission cost, and I don't know if you can break out, how much of that was just to build the rocket versus all the other systems work that need to be done?
The total will be about $450 million over the course of the last 3.5 years. But that is inclusive of everything that was done. I mean, everything from technicians, putting the rocket together to welders, building the rocket a couple years ago, all the piece parts, all the operations, all the modifications on the pad, all the training of the team to get to this point. All that is inclusive in that, and all that was also kind of included or carved out, so to speak, of the Constellation budget. It wasn't additional money to go to the Constellation to go do this. We found ways to use with existing resources to go do that flight over the last 3.5 years. So the cost is spread out what Constellation would have spent anyways, but we used resources to put it together on this flight test.
I'm sorry, just quickly, is it possible is there a cost for the flight itself, just, the launch, I guess, on Tuesday, executing the mission that's separate from all the 3.5-year development, or
I
is
don't
it
have a
all
number unless you
wrapped up
understand the
together?
test team, Ed, but the launch part is relatively cheap.
Yeah, it's a subset of what we've been doing all in our ground processing, which is a subset of the total that Bob suggested. It's extremely inexpensive, if you want to call it that, in order to go launch this particular vehicle, because we don't have cryos on board. We don't have some of those other things on board like a shuttle would. We have solid rocket propellant, which was put together a long time ago, basically for the shuttle program. So our cost for the actual launch team itself on launch day is a subset of all the processing costs we put into place, which is a subset of what Bob talked about.
Any further questions? All right, in that event, upcoming as far as tomorrow, there are no briefings because everyone is involved in the launch countdown simulation. So our next activity will be a countdown status briefing on Sunday morning at 10 a.m. Thank you.
NASA's new Ares rocket is set to blast off for a test flight next Tuesday. The $445 million rocket stands taller than the Statue of Liberty. It's eventually supposed to carry astronauts to the moon.
On Tuesday, scientists are hoping that the Ares 1 rocket is eventually going to be able to fly up to 6 astronauts to the International Space Station, or indeed beyond.
It's a small step towards man's return to the moon. NASA's preparing its first test flight of Ares, its prototype rocket, which it hopes one day will take humans back to the lunar surface and beyond to Mars. In its 2-minute, 30-second flight, the rocket won't even leave the Earth's atmosphere. NASA scientists say this is all about getting a feel for the hardware.
We're purposely going to induce some action in the rocket nozzle, and therefore get some reaction in the vehicle. And by knowing how much input we put to the nozzle and measuring what we get from the vehicle, we can understand a little bit better about the vehicle itself and how it flies.
In fact, 700 sensors will gather data before and after liftoff. They'll also closely monitor its parachute-aided landing back into the sea. As the current space shuttle approaches retirement age, NASA argue a replacement's urgently required. The space agency wants to take it out of service next year.
Main gear touchdown.
The Ares rocket and the Orion capsule, the component which will house future astronauts, are being billed as the next generation of space flight. A lot rides on this mission, but an independent panel of experts to Barack Obama aren't so starry-eyed. They've thrown cold water on the vision, warning NASA needs $3 billion a year to reach its goals. And for a cash-strapped nation, a manned return to the moon, or anywhere else, remains uncertain. Stuart Tinworth, BBC News.
Well, will it work? We'll find out. More on
Ares 1 in Cape Canaveral verhindert. Einen neuen Versuch soll es morgen geben. Der 2,5-minütige Testflug soll erste Aufschlüsse über die Stabilität und Sicherheit der Rakete bringen. Geplant ist, dass die knapp 100 Meter lange Rakete ab 2015 die neuen Raumkapseln vom Typ Orion ins All bringt, um die alternde Shuttleflotte zu ersetzen.
Delays. It was supposed to launch its proposed successor to the Space Shuttle. The Kennedy Space Center in Florida had been hoping to send up the Ares 1X rocket on its maiden test flight, but bad weather forced it to postpone the launch until Wednesday.
Well, it was an attempt that turned into a nail-biter and then a disappointment. We'll look at what kept Ares on the ground. Welcome back. Too many clouds, and NASA has scrubbed the launch of its newest rocket, currently the largest in the world, as a result. It was supposed to lift off hours ago. It is still there on the launch pad. John Zarrella joins us now from the Kennedy Space Center in Florida to explain. And John, looking at the weather behind you, we've all flown through weather a whole lot worse than what we're seeing there. There's no one aboard the rocket. Why can't they send it up?
Yeah, you know, that's a really, really good question, Jonathan. And, you know, the issue was this, that these cloud cover, particularly at the higher levels, the colder clouds, they get those ice crystals in them. And the concern was that if you fly this vehicle for the very first time, you don't know exactly how it's going to perform, things that it's going to do. And if it passes through these clouds, it can form static electricity. And that static electricity might have interfered with their ability to send a destruct signal to the vehicle if in fact they had to do that. So they didn't want to take any chance like that, obviously, on this first flight. So they were waiting for holes in the clouds. At times they had the holes in the clouds, but then the wind picked up above 20 knots. And then at one point, when they thought they were clear with the wind and with a hole in the clouds, then there was a ship, an actual cargo ship that was in the recovery area. So they had one problem after another today, not with the vehicle. The vehicle was fine, but with their ability to actually get off the ground because of the weather and these other little glitches. So they'll try again tomorrow. They've got the same 4-hour launch window, and the weather is expected, Jonathan, to be at least marginally better.
Now, you call it the vehicle. That hardly does justice to the drama of the thing. To look at it, it is a big, gleaming, enormous monster of a rocket. Tell us about it.
Yeah, it really is. And in fact, I've got a model here of it as well. And, you know, this is the Ares 1X. It's 327 feet tall. That's about twice as tall as a space shuttle, and only 35 feet shorter than the old Saturn V moon rockets. And, you know, ultimately, the plan is that they would be able to take these vehicles and actually send astronauts to the moon using this vehicle now. And this configuration out here, the 1X, all of this up here, the upper stage, as it's called, including the capsule, which is on top. They're going back to the capsule. The astronauts ultimately would be up here when they start flying astronauts around 2015. But all this on the vehicle out at the launch pad is all just dummy segments, mock-ups, filled with lead weight so that it duplicates and mimics what the real upper stage would do. All this is the real hardware down here. This is the solid rocket booster, very much like a space shuttle solid rocket booster, and that'll produce 3 million pounds of thrust all at once as soon as they turn on that engine on the launch pad. Again, hopefully tomorrow, and then about 2-minute flight. Total time, Jonathan, 2 minutes. The upper stage will separate, fly off, fall into the ocean. The lower stage will also fall into the ocean, but it will have parachutes attached to it. So just like the shuttle solid rocket boosters, they'll be able to recover this solid rocket booster segment so that they can reuse them. And of course, that will mean cost savings during the life of the Ares program. Jonathan?
Well, we will check in with you tomorrow. Maybe they'll have better luck. John Zarrella, thanks very much.
Hopefully.
Well, there you have it. We've been watching now for some time. I want to take you to the Kennedy Space Center, take a live shot there of the Ares 1X experimental rocket. Mother Nature has been interfering with the U.S. Space Agency's plan to launch this new rocket. But the weather is now clearing. The countdown is now proceeding. Let's listen in a bit. Let's figure out where we are in this countdown.
T-minus 90 seconds.
Perfect. Now we know we've got a minute and a half. This should be quite a show. Now, if you're used to watching the space shuttle take off,
and the handoff of
don't blink, because this thing is going to go up, and I am told it's going to go up very rapidly. This reaches more than a speed of more than Mach 4, about Mach 4.7, I believe. It is a very heavy spacecraft. It is a very expensive spacecraft. This whole shot that is going to last just a couple of minutes is going to cost about $450 million. We're now less than a minute looking at this, you're looking really at the future of the U.S. space program on the launch pad. Let's listen in a little bit as they get ready to launch this. You can bet a lot of people are holding their breath there at the Kennedy Space Center.
And we're now go inertial. The navigation system is activated. Auxiliary power units have started. Solid rocket motor nozzle gimbal checks are underway. Ignition system is armed. Sound suppression water system is activated. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Altitude now 2 miles. Chamber pressure now tapering off as designed. The vehicle is aligned itself with the planned trajectory. We've passed Mach 1 and we're now passing Max Q. We have our Max Q system ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds. Now passing Mach 2. Vehicle now 10 miles altitude, downrange distance 8 miles, and a velocity of 1,540 miles per hour. Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response. We started the last PTI maneuver, structural mode ID, and we passed T plus 105 seconds. Vehicle's now traveling Mach 4, 20 miles altitude, downrange distance 32 miles. The SRM tail-off is observed. Burnout. Our APUs have shut down. CRDs have shut down. BDM fire. And SEP. We show a SEP.
Our signal is frozen here. Looking at that. Now, I don't know, but I don't think that that should have come apart quite like that. I know that one of the stages was supposed to fall harmlessly into the sea, but we'll have to check with NASA to see whether or not this was a success. Those 2 minutes were essentially what they wanted to see. This is a rocket that could carry men to the moon. Let's go back and listen just for a second.
We'll have a burnout orbit parameter in just a second. These numbers were calculated right at burnout. The height of apogee, 21.92 nautical miles. And again, that's not peak altitude because the vehicle was still drifting up, but that is at burnout. Coming up on T plus 190 seconds. After vehicle separation, we have no guidance telemetry return. We're still looking at a good telemetry signal.
All right, they're having some...
And we can confirm the aeroshell separation.
They've been having a little bit of problem with their video that has been coming back there. I don't know how much of that was really expected, but at the same time, what you saw there was a launch, and it appeared to be a successful launch of this rocket. The key question will be whether or not it continued on the exact course that they wanted it to. That's what this test was all about, to see how this rocket performed. Let's take one more look. Go back and take a look at this launch.
1. Ignition and liftoff of Ares 1X. testing concepts for the future of new rocket design.
The Ares 1X experimental rocket, the future of the U.S. space program, going up there as we watch it just a couple of minutes ago. We're getting word that NASA is saying that they had a successful burnout. They exhausted that solid fuel rocket and a successful separation. We'll hear much more on that coming up in World Report and on the iDesk here on CNN International. But for now, let's go live to London and World Sport.
Well, for the second straight day, it seemed Mother Nature was set to sabotage a test of NASA's new rocket. But with just half an hour left in the day's launch window, we had blast off. John Zarrella joins us now from the Kennedy Space Center. John, good to see you. Did everything go to plan?
Yeah, Aisha. In fact, I guess from the standpoint of all those from the NASA and from the team that built the rocket, the ATK team, they couldn't have been happier. The liftoff took place just with half an hour left, as you mentioned, in today's launch window. They were dodging the weather all day, concerns over high clouds that might interrupt communications with the vehicle. And it was, as you can see, a spectacular sight. That Ares 1X rocket, 3 million pounds of thrust, going almost 5 times the speed of sound as it lifted off and left the Kennedy Space Center here. And again, it's the first test of NASA's new Ares 1 rocket. This is a prototype of what they hope to build that will eventually take humans back to the moon and ultimately onto Mars. Now, it'd be a larger version of this for any kind of a Mars mission, but this went a long way in proving that their design, their technology works. Anytime you have flight hardware that you can launch and test it, that does wonders, because the Ares 1X, the Ares 1 program, the whole Ares program has been under some pressure. The White House, the Obama administration science advisors had not yet decided, and still haven't, if in fact the future of U.S. space program includes the Ares, although that's the path NASA's been going down for the past 4 years in designing this as the replacement to the space shuttle. So those that I talked to within the Ares team and the ATK team saying, you know, this does certainly, no question about it, help the case that Ares is the way for NASA to go in the future. So a very successful test. They had 711 sensors on that vehicle, Aisha, and the plan now, go back, analyze the data, make sure everything worked the way they wanted it to work, and that will help them as they continue to develop the full-scale actual flight hardware. Interesting fact to all this, right now, the next time that we're actually going to see a test launch of this vehicle won't be before 2013 or 2014, and that will be the Ares 1Y rocket. Aisha?
And John, just give our viewers a little bit of perspective so that they understand why the issue of cloud cover was so difficult for the launch of this rocket.
First time they launched this rocket, they were very concerned. It wasn't the low clouds that we see around here at the Kennedy Space Center now. It was high clouds up in the upper layers of the atmosphere. They were concerned that those cold clouds, they can form ice crystals. And if the vehicle flies through those cold clouds with ice crystals, it can actually interrupt signals. It would form static electricity that might interrupt their signals, communications to the vehicle. In the event something had gone wrong and they would have had to send a destruct signal to the vehicle, they might not have been able to do it. So that's why it was a real time. They called it a very fluid situation, waiting for those high clouds to clear. They were flying T-38 jets all up and around the perimeter of those clouds and in those clouds, watching as they moved out of the flight path. And as soon as they moved out of the flight path, they gave the go-ahead for the countdown.
All right, well,
Aisha?
We're pleased it had liftoff. John Zarrella joining us from the Kennedy Space Center. John, thank you.
Launch LTD, range weather 232.
Go ahead.
We're getting very favorable reports from the aircraft. We're not quite green yet, but they do think it's any time now, and it looks like it'll last for 10 minutes. That's what they gave us, at least that they can estimate so far.
Okay, copy that.
It is possible it could last longer, but they felt comfortable giving us 10 minutes as an estimate so far.
And Launch Director LTD.
This is Launch Director. Go ahead. I know we're slicing this extremely thin, but I don't know if it would behoove us to look at accelerating that 2 minutes or so.
Let's see if our RCO can support it.
Yeah, we're talking to them right now to see if they can work that.
And as we heard, the good weather availability is extremely narrow, so they're trying to pull it in on the launch time if they can.
LTD range weather, this is Elwa. We are green for the travel electrification rule.
Copy range weather. And let's see then, range weather, you are ready to resume count and go for launch then, correct? Range weather?
Range weather is green.
Copy. And RCO, LTD, are you also go for launch in this, is where we are?
At this time, I'm go for launch.
Okay. And Launch Director LTD.
This is Launch Director. Go ahead.
Okay, we are green on all counts at this time, and our launch team is ready to proceed.
Copy that. You have a go to proceed towards this flight test.
Copy. And for all personnel, we're going to resume in just over 3 minutes and 40 seconds.
LTD RCO 232.
Go ahead.
Also at this time, you have clear to launch.
Thank you, RCO.
Okay, Nets. Attention on net 148. JCP1.
And we're about 90
JCP2,
seconds from
JCPO,
picking up the count.
And you're on 232.
JCP.
And we're 1 minute, 10 seconds from resuming.
The ground computers will hand over to the Ares 1X onboard flight computers at T-minus 80 seconds. Standing by to pick up the count in 15 seconds.
On my mark, time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
11:30 is our launch time.
T-minus 3 minutes, 30 seconds, FTS SNA armed. T-minus 3 minutes, 25 seconds, SRM ignition, SNA armed.
That's the range safety systems being armed. The vehicle will go to internal power at T-minus 1 minute, 59 seconds.
T-minus 3 minutes, stand power secured.
T-minus 2 minutes, 15 seconds. T-minus 2 minutes. Vehicle going to internal power. Ares 1X now on its own power. Now applying power to the DFI, the Development Flight Instrumentation. Flight data recorders are activated. Launch is enabled for the flight control system. T-minus 90 seconds. And the handoff of the ground computers to the Ares 1X flight computer has occurred. T-minus 1 minute. Sound suppression water system now armed. The solid rocket booster joint heaters are being turned off. And we're now go inertial. The navigation system is activated. Auxiliary power units have started. Solid rocket motor nozzle gimbal checks are underway. Ignition system is armed. Sound suppression water system is activated. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Altitude now 2 miles. Chamber pressure now tapering off as designed. The vehicle is aligned itself with the planned trajectory. We passed Mach 1 and we're now passing Max Q. We have our Max Q system ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds. Now passing Mach 2. Vehicle now 10 miles altitude, downrange distance 8 miles, and a velocity of 1,540 miles per hour. Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response. Started the last PTI maneuver, structural mode ID, and we passed T plus 105 seconds. Vehicle's now traveling Mach 4, 20 miles altitude, downrange distance 32 miles. The SRM tail-off is observed. Burnout. Our APUs have shut down. CRDs have shut down. BDM fire. And SEP. We show a SEP. We'll have a burnout orbit parameter in just a second. These numbers were calculated right at burnout. The height of apogee, 21.92 nautical miles. And again, that's not peak altitude because the vehicle was still drifting up, but that is at burnout. Coming up on T plus 190 seconds. After vehicle separation, we have no guidance telemetry return. We're still looking at a good telemetry signal. And we can confirm the aeroshell separation.
It's our telemetry engineer, Mark Levine, making the telemetry calls, assisted by J.J. Joyner.
Up on plus 235 seconds. Our data quality of telemetry is still very good with the remaining TM channels. Not too much to report. The vehicle is gently returning to Earth at the time. We expect it under the parachute, and we were hoping for a visual confirmation from the downrange resources, but as of yet we have not heard from our downrange resources. Next event on the vehicle is the severance of the nozzle to minimize damage on water impact. Passing T plus 325 seconds.
Seven, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Altitude now 2 miles. Chamber pressure now tapering off as designed. The vehicle is aligned itself with the planned trajectory. We passed Mach 1 and we're now passing Max Q. We have our Max Q system ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds.
Liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Altitude now 2 miles. Chamber pressure now tapering off as designed. The vehicle is aligned itself with the planned trajectory. We passed Mach 1 and we're now passing Max Q. We have our Max Q system ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds. Now passing Mach 2. Vehicle now 10 miles altitude, downrange distance 8 miles, and a velocity of 1,540 miles per hour. Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response. Started the last PTI maneuver, structural mode ID, and we passed T plus 105 seconds. Vehicle's now traveling Mach 4, 20 miles altitude, downrange distance 32 miles. The SRM tail off is observed. Burnout. Our APUs have shut down. CRDs have shut down. BDM fire. And SEP. We show a SEP and a tumble motor ignition. And we can also confirm on video. We see both parts of the vehicle tumbling. The first stage as well as the upper stage. Successful separation. Good clean signal all the way. T plus 150 seconds. And we'll have a burnout orbit parameter in just a second. These numbers were calculated right at burnout.
4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Altitude now 2 miles. Chamber pressure now tapering off as designed. The vehicle is aligned itself with the planned trajectory. We passed Mach 1 and we're now passing Max Q. We have our Max Q system ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds. Now passing Mach 2. Vehicle now 10 miles altitude, downrange distance 8 miles, and a velocity of 1,540 miles per hour. Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response. Started the last PTI maneuver, structural mode ID, and we passed T plus 105 seconds. Vehicle's now traveling Mach 4, 20 miles altitude, downrange distance 32 miles. The SRM tail-off is observed. Burnout. Our APUs have shut down. CRDs have shut down. BDM fire. And SEP. We show a SEP and a tumble motor ignition.
6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Altitude now 2 miles. Chamber pressure now tapering off as designed. The vehicle is aligned itself with the planned trajectory. We passed Mach 1 and we're now passing Max Q. We have our Max Q system ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds. Now passing Mach 2. Vehicle now 10 miles altitude, downrange distance 8 miles, and a velocity of 1,540 miles per hour. Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response. Started the last PTI maneuver, structural mode ID, and we passed T plus 105 seconds. Vehicle's now traveling Mach 4.
6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Altitude now 2 miles. Chamber pressure now tapering off as designed. Vehicle is sliding.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Altitude now 2 miles. Chamber pressure now tapering off as designed. Vehicle is aligned itself with the planned trajectory. We passed Mach 1 and we're now passing Max Q. We have our Max Q system ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds. Now passing Mach 2. Vehicle now 10 miles altitude, downrange distance 8 miles, and a velocity of 1,540 miles per hour. Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response. Started the last PTI maneuver, structural mode ID, and we passed T plus 105 seconds. Vehicle's now traveling Mach 4, 20 miles altitude, downrange distance 32 miles. The SRM tail off is observed. Burnout. Our APUs have shut down. CRDs have shut down. BDM fire. And SEP. We show a SEP and a tumble motor ignition. And we can also confirm on video. We see both parts of the vehicle tumbling, the first stage as well as the upper stage. Successful separation. Good clean signal all the way. T plus 150 seconds. We'll have a burnout orbit parameter in just a second. These numbers were calculated right at burnout. The height of apogee, 21.92 nautical miles. And again, that's not peak altitude because the vehicle was still drifting up, but that is at burnout. Coming up on T plus 190 seconds. After vehicle separation, we have no guidance telemetry return. We're still looking at a good telemetry signal. And we can confirm the aeroshell separation.
So our telemetry engineer Mark Levine making the telemetry calls, assisted by J.J. Joyner.
Up on plus 235 seconds. Our data quality of telemetry is still very good with the remaining TM channels. Not too much to report. The vehicle is gently returning to Earth at the time. We expect it under the parachute, and we were hoping for a visual confirmation from the downrange resources, but as of yet we have not heard from our downrange resources. Next event on the vehicle is the severance of the nozzle to minimize damage on water impact.
Seven, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Altitude now 2 miles. Chamber pressure now tapering off as designed. The vehicle is aligned itself with the planned trajectory. We passed Mach 1 and we're now passing Max Q. We have our Max Q System ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds. Now passing Mach 2. Vehicle now 10 miles altitude, downrange distance 8 miles, and a velocity of 1,540 miles per hour. Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response. Started the last PTI maneuver, structural mode ID, and we passed T plus 105 seconds. Vehicle's now traveling Mach 4, 20 miles altitude, downrange distance 32 miles. The SRM tail-off is observed. Burnout. Our APUs have shut down.
Good afternoon, everyone. This is our post-launch news conference for Ares 1X. And here to talk about today's launch and the status of our Ares 1X is Doug Cook, the Associate Administrator for Exploration Systems Mission Directorate at NASA headquarters. Jeff Hanley, the Constellation Program Manager. Bob S., the Ares 1X Mission Manager. And Ed Mango, the Ares 1X Launch Director. And we'll begin first with Doug Cook. Doug?
Thank you. Well, how cool was this Ares 1X flight test? I guess you could say it was turbo electrifying. It's a new word we learned. T-shirts to follow. But it was great. I can't say enough about this team. They've been together probably a little over 3 years now, and they went from a concept to flying this vehicle in that period of time, which, and this is the first time this has been done by a human spaceflight team in a long time. So I can't say enough about the NASA and industry folks that worked on it. It was, in the end, for certain, it was an integrated team. They all worked well together and worked their hearts out to get this to fly, and did just a tremendous job. So can't say enough about that. We're learning a lot. We learned a lot just getting to this point, and now we're going to learn a lot more from the flight test itself. The vehicle flew well, and we're going to get a lot of data back, and we're going to learn a lot that'll stand us in good stead for the future. So with that, I'll let you hear from the guys that know more about it and can tell you all the details.
All right, thanks, Doug. Now to Jeff Hanley, the Constellation Program Manager.
And my comments are very brief. I'm going to let Bob and Ed give you the details of how the day transpired, the last couple of days, actually. I do not want to hear the word electrified stuff anymore. And you, from this point on, won't hear us being worried about it, because on the objective design of whatever we end up flying, this will not be a problem. But the team is tired, but extremely satisfied, as you might imagine, with the result. And we couldn't be prouder of Bob and his team, Ed and his team. They worked through, when I came in tonight, actually early this morning, I was not sure we were even going to launch today because of the lightning strikes in the vicinity of the pad overnight. And this team worked through that methodically, looked at the data, listened to the vehicle, and let the vehicle show us that it was ready to fly. And I'll let, as I say, I'll let them give you some of the specifics of that story. But really impressive that we got to a launch readiness today at all, and we were ready when Mother Nature was ready, and we took our opportunity. And what a great outcome! Flew straight as an arrow, and we're very proud of the result. So. With that, I'll hand it to Bob.
All right. Bob S., our Ares 1X mission manager. Bob?
Thanks. So obviously spectacular day. I mean, absolutely spectacular. The team is extremely excited. The vehicle flew, as we expected, even better than we expected. You saw at the beginning, with the whole cloud issue, and it took us a while to get here. So the last couple of days were pretty challenging to get to that point. As Jeff said, in all cases, the vehicle was always ready. So the vehicle we spent the last 3 years putting together has been ready to fly. It's other issues that we worked through. And today we just saw all that take place. From the very beginning, from the liftoff, you saw the flyway maneuver. It may look a little strange as the vehicle took off from the pad and had a little bit of an angle to it. It's a 300-foot vehicle, and so a little bit of angle, it really shows up a lot when you're looking from it. So from that point, it flew perfectly. It flew just down the plan that we had, right down the line. No significant deviations. We were talking about previously roll torque, what would make the booster roll. So we put a special roll control system on there. It hardly worked at all today. Our simulations would show it fired 20, 25 times. Today it fired 3 times as it went through. So very benign flight. The separation, separated where it should as far as the velocity and altitude, as far as we can tell so far. We had some dynamics on the upper stage, looks like, after the separation. Right now we just have the same video that you may have seen. It'll take us a little while to get some data back to understand the separation, but the separation event itself seemed pretty clean. The upper stage seemed to have some dynamics once we passed by. The booster's in the water. We have the recovery ship out going to get it. No reports or any video to share with you as far as parachute deploy or that portion of it, but because we have a booster in the water, it must have worked pretty well. And so that's the big picture of what we know today. Again, everything worked perfectly, and it was a superb flight. So great team put it together for the last 3.5 years, and we're very proud of everybody.
Thank you, Bob. And to Ed Mango, the Ares 1X launch director. Ed?
Yeah, good afternoon. It is just a fantastic day. I think you heard how happy I was after launch for the team that did this for the last 3 years, and the team that did this for the last week, and the team that did it for the last 2 days. The team really excelled. I can't say enough about the folks that worked together to go make this thing happen. It was a great team, and as you can tell, it was a great vehicle. The vehicle flew very well. The vehicle was ready to fly both days. All we had to do was wait for Mother Nature to get us there. And when she got us there, we're ready to go fly. And I can't say enough about how well the vehicle performed pre-flight and then throughout the flight. The other day I said something about this developmental flight stuff is fun, and I'll echo that again. This developmental flight stuff is a lot of fun. It's a lot of hard work, but you can see the results. And the results are, if you get enough people to work together to make something happen, it can happen. Anything can happen, and that's what NASA does best. We did have some challenges as far as the launch, trying to get off the ground the last 2 days. Yesterday we had a couple challenges. The first is our first time of a new rocket, and so trying to work through everything at the pad and get out of the pad on time and all that took a little bit longer than we had thought. But again, it was the first time. It wasn't that anything was broke. It wasn't that there was any major issues or hiccups with what we're trying to get done. It was just work that had to get done. It took just a little bit longer than we had planned. Today, we had other issues, and yet the work that had to get done at the pad was really clicking along, and that's a learning curve kind of thing. Later on, yesterday, we had the probe cover problem, and that's like a parachute kind of material with a big long string, if you want to call it that, and that fishing line is a 1,000-pound force fishing line. So that's why when we pulled it, the fishing line did not break. And it took a little bit of challenge to get that off of the 5-hole probe. But with a little muscle, both of the folks that were up there working on it were able to get it off and basically rip off the parachute part of it. And that got us behind. I think everyone was in a sigh of relief when that happened. That was one of our major issues to get through. We got through it, and then we're ready to go wait on weather. Unfortunately, weather didn't cooperate with us throughout the day yesterday. So we took a day, we came back. Last night, about 10:30 or so, we got a couple lightning strikes within half a mile of the pad. Just like Jeff said, when I got the call this morning, or last night, I guess, that said we got some lightning strikes, I said, oh, we're going to have a tough time clearing this. And but we also, I asked the team to not work the flight rationale at 10:30. I asked them to go work each step. What does it take to get the power up? What does it take to get to the systems power up? What does it take to start IMUs or FTINU? What does it take to do each of those steps? And as we worked through that, we finally got to the point where we have enough data to build flight rationale. So we didn't get into this go build flight rationale from the get-go and really have to hammer that down. We took it each step. So by the time we got the flight rationale, the folks that supported us from the launch team and the launch support team throughout the country brought together some flight rationale. It was very solid. It's the best solid rationale I've seen as a lightning strike I've seen in a very long time. And because of that, we were able to go fly. That was the only issue we had today other than weather. When weather was good, we looked for the hole in the clouds, we saw it, and we took off into it. Again, another fantastic day, and it's great to work with the development flight stuff.
Thank you, Ed. We're ready now to take questions. So please give your name and affiliation when the microphone comes to you. And we'll start here over on the left with Bill Harwood.
Hi, guys. Bill Harwood with CBS News with a couple of quick ones. On a parachute deploy for anybody, I guess I was surprised that nobody could get a visual on that based on where the ship was. Was it just too far away, or is it a case that nobody's been able to talk to him yet, number one? And for Doug, I realize this isn't a change since before you launched. It's the same situation politically in Washington, but with a test as smooth as this one appears to be, do you have any increased hope of selling this rocket?
As far as the parachutes, the onboard camera did show the drogue chute come out, so we know the sequence started. So that worked out well. After that, we lost the video signal from that. The SRB recovery ship, we had no reports that they saw the parachutes. They do believe they know where it is. I mean, they know where it is. They saw splashes in the water and figured out where it was, but they've been able to track it, and they should be there right now, picking it up. I think so they are there, picking the booster up. But I think it was just where they were, just didn't have a chance to lock onto it and see it.
And from the standpoint of this test, we are working from the recent Augustine report and the decisions that will come from that. During this period of time, we were instructed to continue on the path of the current program, and so we are executing on that. And this test will be of value regardless of any decisions in the future. We're learning about validating our models, our math models for aeroacoustics, the loads, the aerodynamics. We'll understand more about thrust oscillation on a single booster vehicle. It's about learning from it. So we will go through all the steps with the administration on decisions. We don't have decisions at this point, and but all of the data from the Augustine report, all the data that exists, I'm sure will be taken into account.
Jay.
Jay Barbary with NBC. Dr. Cook, to follow up on Bill's question there, it's been 37 years since American astronauts have left Earth orbit. And what you've seen here probably today, one could argue, is 5 decades of experience and know-how. And yet there's a push on for commercialization of space right now. people that are flown a rocket one time successfully out of 5 tries. They don't have this background, this experience, this wealth of knowledge. Bill Gerstenmaier told me that you guys are going to go and sit down and come to a conclusion of what you think should be done after you read the Augustine report. And you're going to go talk, and that would of course be with General Bolden, go talk to the president of what the heck that you think you should do. Now, this demonstration today shows a continuation of experience of it's the 207th successful flight of the solid booster. The man who has the most successful record with a single rocket, the Delta II, General Lester Lyles, came out the other day and said, you guys should continue. This is the path you should go. Nobody should bet the farm on trying to get commercialization in their baby steps to take over the safety of flying astronauts in orbit. So my question I'm finally going to get to, well, you guys are going to go in and sit down and argue facts and real facts instead of pie in the sky?
Well, I can tell you that within the agency, based on what we were learning along the way on the Augustine Commission and the open sessions they had, we've had internal agency strategy decisions trying to work in parallel and understand all the facets of it. I can tell you that in those, Charlie Bolden has led them, and he's listening to all the facts. We're putting all the facts on the table internally with NASA, and that will all factor into this. We are interested though in helping the commercial industry progress, and we do have the COTS program actually in my organization where we are investors basically in their activities, where they meet milestones and we make payments. So we're on a path to help them get there. So, and they're making progress. So, yes, you're seeing experience, but I'll tell you something else that you're seeing. You're seeing actually a pretty streamlined NASA team of people who are, since we haven't done this in a long time, are really kind of learning how to do this from beginning with the concept through design and development and testing and flying. We're somewhat reinventing that as we go. So, but you're seeing some of the best that NASA has putting that to work. So it's all about the team in this case.
Bobby?
Bobby Locke from the Orlando Sentinel. I've got a quick one for Bob, I guess it is, and then a follow-up. You had, we were shown a list the other day of what you would classify as success, and I wanted to know how you would go down that checklist, and also to find out what data did you get back? Did you get any data about bending? I mean, is there anything that you got from the original telemetry that you can share?
Okay, so first question, we completely met our success criteria. In fact, we blew them away. The first one was to roll out. Obviously, we did that one. Clear the pad. We did that without a problem. Fly the intended flight path. We certainly did that one. We've confirmed that. It flew just right down the pipe. And the last one was to learn from the flight. And we've already learned, was an hour and a half, 2 hours from the flight. We're already there. All of our data systems on board worked. We know they're all activated. The 5-hole probe, the one with the socket was going through. They got a little bit of rain overnight as well. There were some concerns there. Early indications are showing all that worked during the flight. So everything so far from a data architecture, the sensors, the system, all that was operational. It'll take a little while for us to go back and get that. In fact, the data recorder itself is on the booster. Even though everything was sent down via telemetry, we haven't had a chance to go back and look at all those besides basic health areas that's working. So far, we're on a path to learn a lot. I mentioned before that the separation seemed a little different than we predicted as far as how the upper stage reacted after separation. So right there is an opportunity for us to jump in and figure out what was different in the actual flight from our models. So hugely successful.
And a follow-up for Jeff and for Doug. For several years now, you guys have insisted that everything's on track, budget-wise, schedule, progress. And every independent look into has come at odds with that, what you guys have been saying. How do you explain the fact that you're having a difficult time selling to the independent people looking in that you guys are where you are?
I can't speak for them. We're doing our job. We're doing we're working through working through every issue that we get. We flew a successful flight today. I don't know that we've seen any, for instance, I don't know that we've seen any indication of thrust oscillation. We'll have to see data later, but the onboard cameras certainly were pretty steady. But that, I don't know if that's the total indication either. But we're working through, and we're keeping our heads down and just doing the job. So I mean, we've been through just this summer. We've been through on another program that's within exploration. We've had LRO and LCROSS. They've been going very well, successful. We've had the Orion preliminary design review, successful in August. We had the first 5-stage engine test of this design in September, and now we've had this flight test. So all we can do is get our job done, and I can't speak for others.
And all I would add to that is that the opinions that are out there expressed during the Augustine public meetings, as well as even the reviews, the external reviews that we've had here for the past 4 years, the Constellation's been one of the most reviewed, externally reviewed programs that I think you'll find, with at least over a dozen external reviews at various levels. We were very informed by those external reviews. They help us to adjust our course programmatically, to help us think of the things that perhaps we're not thinking of and account for those. I was heartened by the comments made during the Augustine public hearings that when the panel recognized through the assessments that had been done for them that NASA has done pretty much what it said it would do with the current program, even under a very dynamic, if you will, budget environment of the last 4 years. We certainly are challenged from a budget perspective and therefore a schedule perspective, but the opinions that are out there as to the executability of the program on the schedule that we have, I think your mileage varies a bit, and depending on the assumptions that you make. So we're just now getting the details of the Augustine report, and we will go in and understand the details of the aerospace assessments that were done. We'll go query aerospace on the assumptions they made, and if there's something that we're not accounting for, we'll certainly account for it in our assessments.
Irene?
Thanks. Irene Klotz with Reuters for either Doug or Jeff. In addition to the analysis from the 1X flight, could you maybe just give us a little overview of where things stand with the Ares program, and also as far as the bigger Constellation program, what's been on hold aside from Altair Lander and Ares 5 contracts while the review process is underway, and however long it'll be before some direction is given, if there's any change? Thanks.
Actually, our direction was to continue on with the work that was underway, and that's what we have been doing. So we haven't. We did put two potential study contracts on hold. We thought that was prudent, but in terms of the Constellation program, we have been working through our schedules, and we've been on track with the work that we're doing through development of facilities and the program milestones, the project milestones. We are continuing to execute according to the direction that we've been under. So, well, some specifics are that we opened the ONC building here at Kennedy. We're continuing to make progress on Ares 1 launch mobile launch platform. We are building an A3 test stand down at Stennis. We're making modifications at Michoud in Mississippi for manufacturing. As I mentioned, the Orion preliminary design review has been held, and we've been doing these tests. As I mentioned, the DM1 test on the 5-segment booster, the this test today of the Ares 1X, and coming up early this coming year, we have a pad abort 1 test for Orion. So these are examples of milestones that we are continuing to execute, working to get them underway and make progress on it.
Marcia?
Marcia Dunn, Associated Press, for Mr. Hanley. Given the criticism in recent months, years of Ares, and you've taken some heat as well, I'm wondering if you feel a sense of vindication today, given the what looks to be a successful flight.
You know, vindication's not really does not describe it well. It's a sense of validation that that the course that we had laid out is executable. An early demonstration like this puts aside any doubts, I think, in our minds, that if we had them, as to the flyability of this particular design. We have a design that will do the country service if it is put into service. The performance of the vehicle was very pleasing, to put it mildly, and I think incredibly satisfying for the Ares project office team at Marshall Space Flight Center that has put so much into that flight test vehicle to bring it to today's results. So it validates for them that they're pretty much on track with where they were headed technically. It was the Ares 1 guidance algorithms that flew the vehicle, the Ares 1 recovery system that functioned to return the booster, and so from that perspective, it's a great validation for the team.
Here.
Clara Moskowitz with Space.com, and this is for Bob S., but also for anybody. I'm wondering if anything about the flight surprised you.
How hard it was to actually get to the flight itself was. We first time flight. You've heard me go to conferences. The first time we're doing a brand new vehicle, all those things together. We expected to have a fair amount of problems during the count leading up to the flight, and a fair amount of problems in the integrated testing over the last couple months. And those were nearly flawless. We had very little problems, if not zero problems, with our primary flight control throughout the build-up and the VAB, our testing at the pad, and the count leading up. So that was pleasantly surprising that we didn't have those kind of problems. Getting there, all the other miscellaneous things, and Ed went through a handful of them that we had today and yesterday. That was the part we didn't expect, as to when it all comes together, when the final push, how these little things seem to come out of nowhere to get in your way. As far as the way the vehicle flew, maybe there'll be some surprises as we look through the data over the next few weeks and a few months. But everything was just how we expected. It was just like the animations we've been showing. It flew at the same speed and the same distance. It just looked much more spectacular in person than it did, in planning. So.
Chris Gebhardt with NASASpaceflight.com. One for Ed. That cover yesterday that you had trouble getting off the probe, had you not been able to get that off, I assume you would have been good to go fly. Correct?
Yeah, we had already started some conversations about can we cut the cord and let the cord just hang there basically, and then fly in that condition. And we already started some of those preliminary discussions. At the same point, we asked if the rope is really a 1,000-pound test. We can pull, and let's go try to pull as much as we can before we go down another route. So we would have gotten to a pretty good flight state. The good news is we did a number of simulations over the last 2 months or so. And in one of those simulations, the sim team, which is diabolical, they threw leaving the cover on, and how do we go fly with a cover that's stuck on? And so we had already worked through the technical part of what that really meant to us in terms of loss of data and those kind of things. And so when it actually happened, we had some homework done that can help us get there. So I can't say we would have flown with it or not flown with it. We certainly would have had a good conversation and probably would have gotten to a conclusion that we could have flown with it.
And probably one for Bob. At SRB SEP today, when the upper stage sort of veered the other way from the SRB, it could look to the untrained eye like the SRB and the upper stage simulator contacted there after separation. Is that something that you think is possible, or do you just think it was the aerodynamic effect, an unexpected aerodynamic effect on the upper stage that caused it?
Yeah, it was tough to tell. We all saw the same video. It's tough to tell for sure. I don't think they actually recontacted. but we'll know more as we look through it. The nominal separation would have separated at the plane, and the upper stage keep going, its merry way, and the booster kind of back off away from it. And we know the booster separation motors, deceleration motors fired, the booster tumble motors fired. So that sequencing seemed to work well. So if anything, that we would suspect could be the separation conditions. That we have a little more angle than we thought we did, with aerodynamics a little differently, whereas maybe at a higher dynamic pressure than we expected. There was something that was that precluded from going straight on. We don't know anymore at this point. It was very interesting, and said before, interesting is good. We love those kind of things, to go and dig into a little more detail. So we'll let you know when we know more in another couple of weeks. But right now it was different than we expected, but it really wasn't dramatically, wasn't nothing wrong with it, just different.
The behavior of the booster was perfectly as expected, because it is designed to tumble.
Right here.
Gina Sinceri, ABC News for Jeff Hanley. Did you ever want to go outside and shake your fist at the weather gods and say, why me?
Well, I will tell you, I wish Kathy Winters was here, from our range weather officer, because if somebody was in the middle of the dynamo that was the on again, off again nature of the last 2 days, it was Kathy Winters, and she did a tremendous job searching for the right conditions, and these were rules that she's required to honor. She didn't create them, and we're very lucky to have someone of that caliber, and the cooperation of the range. The range worked very hard to get us launched today, and they were ultimately successful. We of course would have liked to have had more windows to shoot for, but working out today, I told a few of my folks, I was, in retrospect, looking back at it, happy if you could say that we didn't go yesterday, because if it had launched yesterday, we would have lost it in the clouds, and we collectively would not have been able to see it like we did today. So the weather gods parted the clouds for us today, gave us the right conditions, and we put on a good show. So.
Jim Siegel from the Celebration Independent newspaper. Question for Bob and Ed. We saw the replay tapes after the launch. They were very good, spectacular, in fact, very interesting. And I think the American people will have a couple of questions about what they may have seen when they see those replays. For example, there appeared, number one, to be a kind of plume coming off of the top of the spacecraft as it was reaching its apogee. And secondly, when the top sections of the rocket on separation appeared to fold on each other and then kind of tumble, was that expected or not expected?
Yeah, so the first one, what that view was, really was a reflection off the front of the camera, right in front of the booster. And as you can tell, as it went further and further up in flight, it got brighter and brighter, but it mimicked the booster plume getting bigger and bigger as it expanded. So that was just an illusion based on the camera that there was something up front. Secondly, the nominal plan for separation really was for the upper stage and for the booster to stay in line, and the booster would back away from it and then start tumbling. This looks like the upper stage kind of folded back a little bit, and that's all we really know, is that it did that. It's not unheard of in our simulations. If you simulate a higher rate at separation or a higher angle at separation, you would get that effect. So we've seen that before in simulations. All it shows that we were kind of off the middle of the pipe at this point, sometimes a little off nominal, but not unexpected, but just off nominal.
All right, let's go to the back here and we'll work forward. No.
Hi, Craig Cavalt with Spaceflight Now. Over the last year and a half or so, there's been an awful lot of attention in an engineering sense paid to the roll torque issue, and today it sounds like it was moderate, if not minor. How significant is how you were able to prove that out today from an engineering standpoint in terms of validation of this whole design?
Let me answer from what we saw today, and then I can let Jeff go through what that means as far as the areas and implications there. For today, we saw the roll control basically do three couples of firings. That's it fires in one direction and gets it rolling, and then has to fire to stop the motion. So 3 of those sets is what we witnessed today based on our early data. We've done many simulations showing us that 20 or 25 times that it fired based on the roll torque models that we put into our simulations. So what they showed today is there was a whole lot less roll torque in this booster, in this vehicle, than the miles that we've been using is kind of like the worst case. So much less than expected. What that means to the team,
well, so it's another data point for us, right? And we've been instrumenting shuttle boosters out on the test stand out in Utah when we do engineering motor firings out in Utah. We've been instrumenting those for the past few firings to also look for any kind of roll component or roll torque, if you will, to the output of the motor. And that includes the proper instrumentation of the recent Development Motor 1 firing. In all cases, the data is, we're building a data set that tells us that this roll torque is very small if it exists at all. And so that's going to give us confidence to then go back and relook at the Ares 1 design and what extent of a roll control system do we really need. We were conservative with the sizing of the roll control package on Ares 1X because early on, 3 years ago, we weren't sure exactly what that roll component was going to be, the behavior of the solid in that axis. And we've been building that data set as we go. This is a great data point for us.
Yeah, this is really a part of flight testing. You generally will design for your uncertainties. So if you can have a nominal what you expect, but there are always uncertainties on that and combinations of things that can happen that would tend to throw you off nominal. So you tend to cover all those cases to make sure you have a robust design. But flight tests like today helps you learn about that. You can reduce your uncertainties and design for the real case. So that's why you do these, and we always learn from them.
Totally different topic, really, for Ed. And please take this as a question and not a criticism. I know it'll sound the other way, but from watching an awful lot of countdowns here over many decades, the internal communications, both today and yesterday, seemed a little rocky. I wonder if that's a fair assessment of getting that information exchange back and forth among that team, that group of people, and whether it's worth looking at in your post-mission analysis, really.
Okay, well, I would say the communications this time was different than what we've seen on many shuttles, and it was designed to be a little bit different. We are, besides looking at the hardware and how the hardware is designed, we're also changing some of the ways we do our test team, and I think I talked about those a little bit the other day, how we're doing a launch authority team, how we're doing the prime launch team. I can tell you the prime launch team did outstanding. They did outstanding both days. The launch authority team did outstanding both days. I think the communications areas that it all worked very well, but you're right. After two attempts yesterday and today, we're going to increase on that learning curve. The more flight tests we do, the better off we'll be, and we'll learn from those experiences. Like any flight test, it's a learning experience. So we're going to take what we've experienced in the last 2 days, and then take those lessons from that and see how we need to improve and or change how we do our communications. I think the communications we did with the range and weather, I can't say enough about how the range supported what our needs were, and how the launch weather officer, Kathy Winters, did outstanding in supporting what we needed. We definitely put her in a box sometimes, and she was very calm and said, this is what we got to go do. And so that communication I thought also worked very well. But like anything, you take your lessons and then you immediately go figure out what you can improve on. So if we were to go launch another test rocket in a short period of time, we would take this team and it would even be better than it was today.
Back here.
Steve Lee from the Denver Museum of Nature and Science. To anyone or perhaps everyone on the panel, what messages would you like today's test flight to be sending to the next generation of rocket scientists that just happened to be in middle school today?
This is darn fun stuff.
Also the fact that we do these things once every couple of decades, it seems, and it's unfortunate we do it that way. But this is the time to do it again. And so middle school is the perfect age. High school is the perfect age to come do this. And we did it for Apollo. We did it for shuttle. And now we're ready to do it again. So this is the time. So come join us.
And we're at the beginning steps of the next phase of exploration. So this this is the sort of thing that when I was younger inspired me. This is the next step in human exploration, and there is interest in definite interest in going beyond low Earth orbit to discover new things out in the solar system, learn more about the solar system that we live in, and so this is an exciting time. This is really the first big step we've taken in that direction in a long time, and for me, for these guys, it's been 3 years. I think the first study that I helped lead on exploration was about 20 years ago, if I'm not mistaken, and so it's taken me a little longer than it has them to get to this point, but it's. I think you're also seeing the efforts of teamwork, and really ultimately, in all ways, this is about people. It's about discovery and the things that we learn for society and our country, and it's about the people who do these efforts, the teamwork, the leadership, all the things like that are learned along the way, and so it's those are the kind of messages I think I would like to see go out.
Todd?
And I would just say that it proves that anything is possible. When I was a young kid trying to figure out what to go do, and I saw NASA and I saw the space program, that those guys can do anything. We can get to the moon, we can build a space station, and so today what you saw, I think, was the first step, which is what I told my team post-launch, was they help prove anything is possible. And like Doug said, it's all about the people. The metal is there, all the engineering is there, but it's the people that make that happen. And for future engineers or whatever, we need those engineers in order to make these kind of things happen, in order to make anything happen that is great for this country.
Todd Halverson of Florida Today. I suspect a lot of those youngsters might be watching TV today and saying, "Do it again." And you know, your direction from the White House right now is to plunge ahead with Project Constellation and the development of the Ares 1 rocket. And I'm wondering if you could just lay out for us what some of the big milestones are coming up and when we're going to see them. And right now, when is Ares 1Y? What will that test be like, and why is it going to take so long to get to it?
Well, great question. Well, the next thing on our plate, as I think either Ed or Bob referred to, is Pad Abort 1, which will be next spring, and that'll be the first test of the launch abort system on the Orion. We have a boilerplate capsule that's basically another one of these highly instrumented models, if you will, similar to the upper stage simulator on Ares 1X. We've got that delivered down to the White Sands Missile Range. It's been outfitted with hundreds of measurement instruments, and it's being loaded with parachutes. Its abort motor has been delivered to White Sands, and it will be fired there in the desert sometime next spring. And will demonstrate the ability of that system to safely motor the capsule away from the launch pad and allow the capsule to land safely, which is a key part of and will be a key part of any human launch system as far as safety is concerned. Beyond that, you know, our flight test program is something we constantly have under review. With respect to schedule, budget, content. Ares 1Y is something that we've had in our plan for quite some time, for March of 2014, off of the launch pad here, launch pad 39, 39B. It was scoped to be another suborbital flight that would demonstrate the operation of the first stage, the 5-segment first stage, and the launch abort system after the separation event, what we call a high altitude abort. We have studied putting an engine on that flight. It was originally defined in a time frame when the engine would not be ready, and we continually revisit that to see if we can't get an engine to the upper stage to actually fly on that flight. And if we could at least start the engine and prove that the engine will start at altitude. So we continue to review that. We are probably paced most by the availability of budget to buy long lead parts for both Orion and Ares. And we've been, we were under a continuing resolution for the first half of 2009. We're under a continuing resolution now, and that puts pressure on a program that wants to be ramping up to its peak right in this time frame, building toward the critical design review. Our critical design reviews will be end of next year for Orion and into 2011 for Ares. But progress will is already underway to build components. The J2X engine is being manufactured now. It's passed its critical design review. It's being manufactured now. It will go into test in early 2011. The Orion is the first copy of the Orion's being welded together right now at the Michoud facility down in Louisiana, and that will be our first ground test article that we'll put through a bunch of testing through the next couple years to understand the way that system behaves. Buying the parts in terms of electronics and batteries and so forth, getting those systems assembled and tested is work still ahead of us. But the successful PDR in August was a big milestone for the Orion team, and they're going to move ahead quickly to their CDR at the end of next year. And then the work here at the Kennedy Space Center. I mean, this week the Orion team should be taking delivery of some tooling for the factory here. Orion's factory is here on the premises. Orion's will be built here at the Kennedy Space Center, and that is coming together. They're largely ready to start assembling Orions just as soon as they can start to receive the parts. The launch complex is undergoing its mods. If you drive by the vehicle assembly building, you'll see the mobile launcher under construction. 2 tiers of the tower already up, with a third tier going up perhaps this week. The vehicle assembly building with the designs for the inside of the vehicle assembly building are complete. We're about ready to go out for a procurement on that, so that we can get that done, and so on and on. We're continuing to make progress on the system. And as far as the flight test schedule is concerned, we will be looking at our opportunities to perhaps do more flight testing, but that'll also be predicated on the budget.
James?
James Dean from Florida Today. For Mr. Hanley or Mr. Cook, to your point about the budget, how much would an increase in funding of the magnitude that the Augustine Commission recommended help, if at all, in speeding up your IOC or meeting it? And likewise, is there anything about today's test, if the data comes back just with everything looking extremely positive, how much does that increase your confidence in making your target, or is there even a potential that it could help move it up?
Well, I think more money sooner is good. Right, it gets those parts purchased. Right, gets them into the supply chain. These systems take about 3 years to build. From the time you put in the order for an Orion, 3 years later you'll get a finished copy, or a rocket. That includes the supply chain for the parts. So you have to get the design done. You have to know what you want to buy, and then put your orders in and get your parts, and then you can start assembling the spacecraft. So that by definition is going to take 2-3 years to do. So that's what puts us out in the 2014 timeframe for this system. If you'd seen a picture of our funding curve, you'd see that there's this flat nature to it through this fiscal year, FY10, and then it jumps up markedly, and that's just the nature of what we're doing. We're trying to develop this new system while we fly out the space shuttle, and then apply some of the money that had been used for space shuttle to the future development of these new systems. And so that's been a tight fiscal management challenge for the agency. I think as Augustine Augustine panel commented, it was that we've done pretty much what we said we would do. We all would like to fly sooner. I wish Orion was flying in 2012 or 2013. We had a plan, as you know, at one time for the first human launch of Orion to be in September 2013. The funding didn't materialize for that, so we had adjusted our schedule. That's really the what we have to do, budget cycle to budget cycle, and we manage that very closely. And we will get the system flying as early as the funds available allow.
Any questions on this side of the room? Yeah, right here.
John Mangles from the Plain Dealer in Cleveland. I guess for Jeff, I know you guys didn't want to hear this word again, but I wanted to ask about tribo-electrification. What would it have taken to certify the vehicle, and can you give us some sense of what the discussion was about why not to do that?
Besides being a big word, it's a it's a big subject. It's not so much certifying the vehicle. It wasn't really a conscious decision that we made. We're not going to do the program. There's a lot of different ways to address it. And really, it's to protect the vehicle from itself. If the vehicle flies through a cloud or something like that, it could cause enough charge on the outside of the rocket to either interfere with communications or affect the electronics. So the concept is there for a good reason. There's a few different ways to go do that, one of which that vehicles do. You can coat the vehicle or do something that would help dissipate the charge. And that's unusual. We don't do it for the shuttle. We don't do it on our rocket. The other way is to show that your vehicle is not particularly sensitive to that effect. It may happen, but your electronics may not really be affected by it. And so that's not a rule that we have, a weather rule we have for shuttle. And we inherited a lot of shuttle rules and a lot of shuttle people. And so when we went through 1X, we didn't fully appreciate, I think, the implications of some of these rules that were meant for brand new rockets or brand new launch vehicles and how it applies to us. And we believe, and we've done analysis the last few days that shows that our vehicle isn't sensitive to it either. What we didn't do is go to the range up front and said, here's our analysis that shows that effect, therefore we don't have to go through and follow these stringent rules. So part of it is the learning curve, understanding with flight tests what that really means, differentiating ourselves from the last couple of decades of shuttle. This was not something that we were used to dealing with. And again, if we did it again, in fact, next week, we could probably show that we're good with it, wouldn't have these constraints. But that one just kind of was a surprise to us. It really was a bigger implication to us than we expected.
Just one more thing that you learn from flight test is you run up against these things as you go, and you learn from them. So this is something that we now know that we're going to be working with. So we're learning from it. So just one more thing that shows the value of what we've done.
Hi, Rory O'Neill with Westwood One Radio. One quick one. Do you know how many launch times you actually set over the past 2 days? Did anyone laugh? I mean, we were laughing in the room at one point, especially yesterday when it was the sock, the ship, the weather. Is there any point where it just became humorous? Because it did seem like for a while like a comedy of errors for about a half-hour stretch there yesterday.
Only laughed to a point. After that, we started crying, I think. But
let's see. I don't look at it as a comedy of errors as much as it beats any reality show I've ever seen. See, I don't know the exact number, although there was actually a bet going on how many we would do today. In reality, I would say that we really did two. We got down to 4 minutes yesterday, and then we continued on down, and then we ended up having the rule violated about 2 minutes and 39 seconds or so prior to launch, and so and then we tried to recycle from there, and then by the time we got through recycle and looked for more opportunities, we lost the rest of the window. So I would say officially, in my mind, we tried twice yesterday, and the second time we lost window. Today, we moved the launch time a couple times, but in the end, we only went down from 4 minutes down to 0 once. It is different than shuttle. Shuttle, we can hold for a long period of time. When the problem is picked up, we pick up the count right away. Here, with again, you got shuttle hardware, you got Atlas hardware, and so in this particular hardware, you got to set a resume time, and because of that, it looks like we have multiple attempts. But it's how you work the avionics between the flight and the ground, and it's different than shuttle, so it looks different. But So if someone can count them, I like to know how many times we moved that launch time. But in my mind, it was twice yesterday and once today.
Yeah, we got. Oh, go ahead.
Let me just comment. I think I was very impressed with actually with the team and how they worked through the various problems the last 2 days. Yesterday and today probably were unlike maybe even the hardest sim that they were seeing in their launch simulations. Between getting down to the wire and having a ship go into the area and the sock. That was high drama, and cheers went up when it came off. So that was an enjoyable drama. We really were kind of looking for a replay on that one, but so I think the team hasn't actually. They've worked hard and they've been very professional in working through the issues, getting past the lightning strike situation this morning was done probably in record time, but done thoroughly. But I think the team enjoyed working together and enjoyed the light moments when they came. So it's all a part of being with the team or part of the team.
Bei der Premiere flog die Rakete etwa 46 Kilometer hoch und 241 Kilometer weit. Die untere von 4 Raketenstufen stürzte anschließend an einem Fallschirm in den Atlantik. Die derzeit leistungsstärkste und größte Rakete der Welt soll die veralteten Space Shuttles ablösen und Flüge zum Mond oder gar zum Mars ermöglichen.
It was launched from Cape Canaveral in Florida after 2 days confined to the launch pad by bad weather. NASA intends it to replace the space shuttle, but the costs have frightened the White House. We have a report from the BBC's Pallab Ghosh. At least we had a report from the BBC's Pallab Ghosh. I'm not sure if we have it now. We do have it.
Right now, the Ares 1X vehicle on the launch pad is ready for flight.
After 2 days stuck on its launch pad because of bad weather, all systems are now go for NASA's new rocket.
The final countdown has begun.
4, 3, 2, 1. Ignition and liftoff of Ares 1X. Test.
The Ares is setting off on its first ever flight. Rising beautifully into the sky.
2 minutes into the flight and 25 miles up, the rocket's big test. Separation of its lower booster section.
Our APUs have shut down.
It goes as planned.
Shut down, medium fire. And SEP. We show a SEP and a tumble motor ignition.
For NASA, it's been a successful test flight.
The first launch of any new launch system is full of risk, unknowns, etc. So it has a slightly different feeling. All launches are exciting, but I think first launches of anything are a little more exciting. And that's the way I feel about this one.
The plan is for the Ares rocket to take astronauts to and from the International Space Station, and in time take them to the moon, even to build long-term outposts. But a presidential committee has ruled that the program is too expensive.
The committee is very doubtful that Ares 1 is worth doing, and almost certainly the White House is going to decide to terminate the program.
So despite a successful test, the first flight of the Ares 1 may well be its last. Pallab Ghosh, BBC News, at the Kennedy Space Center in Florida.
Entwicklungsarbeit hat die neue US-Rakete Ares in Cape Canaveral ihren ersten Probeflug bestanden. Die sehr viel leichtere Rakete könnte in ein paar Jahren die lang gedienten Shuttles ablösen und später gar zum Mond fliegen. Die Finanzierung der Pläne ist aber noch ungewiss.
Ihrem wichtigsten Projekt Hoffnung einer ganz neuen Raketengeneration. Die könnte für die US-Raumfahrt so wichtig werden wie einst diese riesigen Saturn V Mondraketen oder wie die Space Shuttles, die allerdings auch Rückschläge und Katastrophen mit sich brachten. Die Space Shuttles gelten längst als zu anfällig und zu teuer. 2010 sollen sie eingemottet werden und so könnte die Zukunft aussehen. Eine Rakete so schlank wie ein Bleistift, das ist die heute getestete Ares 1. Sie soll Menschen ins All befördern. Die wuchtige Ares 5 wäre dann für den Schwerlasttransport da. Technisch scheint Ares auf dem besten Weg zu sein. Die Zweifel sind eher finanzielle. Eine Regierungskommission hat gerade durchgerechnet, das Geld dafür sei gar nicht da. So ist das ein sehr banger Jubel der NASA-Leute über diesen gelungenen Testflug heute. Hildegard Werth berichtet.
Vergangenheit trifft Zukunft im Weltraumbahnhof in Florida. Auf einer der beiden Startrampen Space Shuttle Atlantis, auf der anderen die neue Ares-1-Rakete. Sie soll Amerikas Taxi ins All werden. Die NASA braucht neue Raketen, wenn sie raus will aus der Erdumlaufbahn. Das kostet Milliarden, die der Raumfahrthaushalt nicht hergibt. Noch hat Präsident Obama nicht entschieden, was ihm Amerikas Präsenz im Weltraum wert ist. Die Technik wenigstens, sie hat funktioniert. 46 Kilometer hoch steigt die Rakete. Dann ist die erste Stufe ausgebrannt, die zweite ist sowieso nur eine Attrappe. Schlips ab, das ist der Preis, den der Flugdirektor für den Erfolg bezahlt. In Cape Canaveral brechen harte Zeiten an. Wenn die Shuttle-Ära endet, gehen tausende Jobs verloren.
10 Jahre haben wir hier die Bauteile für die internationale Raumstation vorbereitet. Wenn die ISS fertig ist, wird hier alles leer sein.
Frühestens 2015 ist die Ares-1 serienreif. Sie soll die neue Orion-Kapsel mit 4 Astronauten ins All bringen, zum Beispiel zur internationalen Raumstation. Pech für die NASA, die ISS ist dann schon fast am Ende ihrer Lebensdauer angelangt. Nicht vor 2020 sieht das Zukunftsprogramm Flüge zum Mond und später zum Mars vor. Dazwischen liegt eine lange Durststrecke. Aber eigentlich kann sich Amerika große Sprünge im All gar nicht leisten.
Die Ares-Rakete kommt zu spät, um Astronauten und Material zur internationalen Raumstation zu bringen. Und sie kommt zu früh für einen Flug zum Mars. Das ist die wohl teuerste Rakete, die wir je gebaut haben.
Unverdrossen hat die NASA diesen Sommer neue Astronauten angeheuert. Falls die je mit der Ares-1 fliegen, werden sie auf dem Rückweg ins Meer plumpsen, wie in der guten alten Apollo-Zeit.
Das ist extrem kompliziert. Die andere Frage war, kommt es zu solchen starken Lenkschwingungen, dass die Rakete vielleicht sogar zerbricht? All das ist nicht passiert. Insofern war es ein voller Erfolg.
Nur 6 Minuten lang fliegt Ares und etwa 46 Kilometer hoch. Wie geplant trennt sich nach 40 Kilometern Flugstrecke die untere Raketenstufe ab und stürzt kontrolliert ins Meer. Gebremst von Fallschirmen fallen die Raketenteile in den Atlantik und werden von Schiffen geborgen. Anschließend werden sie ausgewertet, zusammen mit Messdaten von rund 700 Sensoren.
Es wird ja nur die erste Stufe getestet. Die zweite Stufe und die Kapsel, die oben drauf sitzt, sind ja bloß Dummies, also Projekte, die eigentlich nicht mit Leben erfüllt sind. Wir haben erst 2012 den Erstflug von der gesamten Rakete und dann vielleicht 2015, dass wir einen bemannten Flug haben.
Schon 2010 aber wird das Space Shuttle ausgemustert und ohne eigenes Raumschiff sind die USA auf Mitfluggelegenheiten bei den Russen angewiesen. Diese Schmach sollen die Ares-Raketen so schnell wie möglich beenden und sie sollen sogar noch deutlich weiter fliegen.
Der große Unterschied zum Space Shuttle-Programm ist, dass die Ares-Rakete, es ist eine ganze Familie geplant, später auch mal zum Mond fliegen könnte oder zum Mars.
So eine tolle Rakete hätte die NASA nur zu gern und sie will sich gleichzeitig auch weiter an der internationalen Raumstation beteiligen. Für beides zusammen aber reicht das Geld bislang nicht. Nach Berechnung einer Regierungskommission fehlen 50 Milliarden $.
Jetzt muss sich die Amerikaner überlegen, wollen wir dann wirklich zum Mond und zum Mars? Denn das ist eine Entscheidung, die gilt für die nächsten 30 bis 40 Jahre. Die kann man dann nicht einfach umstürzen. Nein, diese Entscheidung muss gefällt werden. Aber wenn es irgendwo dort draußen hingeht, allein wenn es nur zum Mond geht, brauchen wir eine Rakete. Und das ist die, die wir heute getestet haben.
Die Fortsetzung der bemannten amerikanischen Raumfahrt wird eine der schwierigsten NASA-Missionen überhaupt. Denn ein gelungener Testflug ist zwar ein erfreulicher technologischer Erfolg, die wirklich große Hürde aber hat mit sehr viel Geld zu tun. Und da hat Houston möglicherweise ein ernstes Problem.
all released. Jamie, we're done with the boat. Copy that. All right.
How much space you got there, bro? We got about. So it's been 2 days and 3 hours, I guess, or actually almost 2 days exactly, isn't it? 2 days and 7 minutes. And since that point, we've done a little bit of data review, looking through our telemetry coming down, and looking at videos mostly. The data recorder on board is still on the SRB. We'll hopefully get that off sometime tomorrow. So that really contains a lot of our information. I will say, big picture, that all of our data did come down through telemetry to the ground stations. All that's being recorded. As we speak, the instrumentation guys are going through and playing that back. They play it back basically at a half speed or quarter speed. And right now they're going through what they call the data integrity check. It's not so much to see if the particular level was a particular PSI, but is the data valid? Is there any kind of erratic behavior that would make you discount that sensor? So that's the first step, is go through and see if all the data makes sense. Then they go through again and actually try to interpret what the data means. So just a fairly rigorous process to make sure they understand what's there. So let's just walk through the flight. So we had to lift off at T0. You saw from the video, everything was good. Everything was nominal. We had nominal case pressure in the booster, so that all worked out well. The flyaway maneuver, as expected, put in a 1 degree nozzle input. That's probably the biggest. Not probably, that was the biggest input we put in during the flight purposely, and we knew that. And so that worked out well. It actually did exactly what it was supposed to do. It took the vehicle and pointed it away from the pad. And just a reminder, the flyaway maneuver was designed to protect the upper portion of the fixed service structure, all that structure. That's why we wanted to fly away from it. And it did just that, so that worked out really well. In order to do that, you have to essentially point the vehicle away, which points the flame closer to some areas that are not hardened for shuttle. So for the first 10 or so shuttle flights, when we did this kind of thing, we had different areas cause damage in the pad. And we're flying a shuttle pad, so we didn't specifically harden other areas in the pad. So we knew that the flame would impinge upon some different areas of the pad than we did for shuttle at the lower areas. And that's as expected, and we saw that, of course. We saw in the flame trench, we saw some fondue fire come off, just like for a shuttle flight, so that was expected. There was no difference there than any other shuttle flight we've seen recently. No bricks came off. So that was all good. You've heard we had a leak at the pad. There was some oxidizer and fuel hypergals lines that were there. Those lines were there from the shuttle flights. We don't use them. And those are right at the MLP level, the 95-foot level. And so that's the area, as expected, got the most impingement due to the flyaway maneuver, different than what we'd see for shuttle. Those lines were there from shuttle. They were drained. They weren't used for this flight, but there were residual vapors inside it. And that's what the crews who were out there smelled when some of those lines got damaged. So those have been safed and then resafed, I think, a couple times to make sure, and there was no concern to anyone. People were sent to the clinic for observation to make sure there was no issues, but there were no issues. It was a small leak, just for precaution. So that takes care of the liftoff area, and once we cleared that initial area we took away from the pad, you could see it visually. It was pretty pronounced how we flew away from the pad. And all that worked really well. Again, there was no damage that was noted at the upper parts of the fixed service structure, and that was the point, was to try and keep it away from there. After we cleared the pad, we started our roll maneuver, about 6 seconds, and we put in and received about a nominal roll rate of 5 degrees per second. And so we did our 90-degree roll at that point. The video showed it was very, very stable, with no oscillations or overshoots, so that was a very good maneuver for us. The vehicle accelerated through to max Q. Our maximum dynamic pressure was about 900 PSF, pounds per square foot. We'll confirm that again once we get the air data from the flight and from the data recorder. And this is looking at the telemetry data and the video as where we headed up for altitude. That was pretty close to nominal. We had a range from about 750 to about 1100 PSF is about what we expect for this range. Right down the middle, no dispersions would have been about 850. I think we saw it in our press numbers. And so we hit 900, which is pretty close to dead on. As far as the ascent itself, the booster guys, first stage and ATK have been looking at all the data. Everything looked great. This was the oldest booster we've ever flown. It looked just like a shuttle flight, as far as they said. All the parameters were right in the middle. There were no dispersions. all the pressures and oscillations where we typically see for a shuttle flight. As you know, we also measured the for thrust oscillations. We had 2 of the sensors that were tied to measure thrust oscillation area. So it's only a preliminary look, but so far the oscillations look very small, similar to what we'd see for a shuttle data or for that one test firing we did when we instrumented it as well. So we didn't see anything unusual or anything even remotely high enough to the thrust oscillation levels that we've been talking about, or people have talked about for a couple of years. So that was very benign. It was very little there. Again, we'll get the data back from the recorder, which is very high-speed data, and we'll verify that. But at this point, there's nothing that indicates that thrust oscillation was even a factor in this. We continued up. We did a separation at 125,000 feet, about Mach 4.6, and both of those were pretty much as predicted. We looked at the video and multiple video views, and we did not see any recontact between the upper stage and for the first stage. If you look at one view, it's tough to get any depth of perception there, but we looked at it multiple views, and we're convinced you can see blue sky. A little more about the separation. Our separation rates, at the rates of the vehicle at separation, I should say, we're supposed to be within 2 degrees per second in pitch and yaw, and 3 degrees per second in roll. And indications we had the last couple of days, those are all with less than a half a degree per second. So the flight control kept the vehicle very, very stable. It wasn't rotating at all during the separation, so it was very solid. After we saw the upper stage tumble, and I think on 2 days ago at the press conference, I mentioned at least the phrase that Bill had in his article was a little different. So we went back and looked at all the 5,000 dispersed cases that we ran, and we found thousands of them that matched what we saw. So my comments were incorrect when I said a little different. In fact, we have, my guy sent me today, animations just from that were done a couple months ago, showing almost exactly what you'd see in the video. And we can try and show those later next week, and we could get those out to show you that our models did predict what we saw. And it was the manager who didn't say it right. In fact, the vehicle, and my guys reminded me that there's 100,000 pounds of ballast in the very base of this. There's about 130,000 pounds of ballast total. 100,000 of it is at the very back end of the upper stage. That simulates where the liquid oxygen would be for Ares 1. And there's about 30,000 pounds further forward in the upper stage to simulate where liquid hydrogen would be. So the center of gravity is very far aft in this thing once it's by itself, and the center of pressure is more towards the middle, a little forward. So it's inherently unstable. So with about 100 or about 90 or so pounds per square foot of dynamic pressure in an unstable vehicle, it's no wonder the simulations show just what we saw, is that once you separate, there's nothing to control it. Now, as a reminder for Ares 1, there's an attitude control system on it. We don't. And so as soon as you separate, there's an attitude control motors that will keep the upper stage where it needs to be. And then the J2 engine will kick off as well and have an active control. So that is something that's very, very different between 1X and Ares 1 is the upper stage part of it. So we went through, you saw the upper stage tumble, the booster tumble motors did fire it a few seconds later, and the booster did its yaw rate as expected. That looked really good. That continued for a while, and then the nose cap jettison occurred. I don't have the T plus time, but it was on schedule, nominal time. The pilot chute came out as predicted, and the pilot chute pulls out a drogue chute, and so the drogue chute came out great. All those worked well, and the drogue chute stabilized the vehicle, and after it was tumbling, the drogue chute got to be a pretty near vertical orientation as it started coming down. So that part of the sequence worked really, really well. The secondary separation system fired, and we deployed the forward skirt extension. I mean, that's the section where the parachutes are actually located in, although the parachutes are actually attached to the section below. That worked. The drogue chute pulled that forward skirt extension up and away from the vehicle, and there's a video I think we'll get out to you guys sometime next week. You can see all that coming out, and the parachutes deployed as planned, and the parachutes have these parachutes have two conditions. There's a reefed condition and disreefed, and if you're not familiar with parachutes, when you deploy a parachute, there's a really big opening shock when it opens, and so that's tough on the parachute more than anything. So what you do is you put a line in there so it only opens about halfway for a while, and that's called the reefed position. Then after it's open for a little while and the shock dissipates, then you fire a little pyro and open it the full way. That way there's a two-step process to get to the full parachute load. And it's very, very common. Parachutes all over the world for a lot of things do that approach. That just keeps the shock loads in the parachutes relatively low. So the parachutes came out in the reef position, and they all inflated, all three of them. So that was good. Soon thereafter, one of the parachutes failed, and it's tough to tell exactly from the video. We're hoping to look at the parachutes sometime over the weekend or Monday or Tuesday, and it appears that the suspension lines themselves may have failed as opposed to the parachute material. Again, we'll have to look at it in person to verify that, but that's what the video seems to imply. So when so we had two parachutes then in the reef position. One was kind of trailing, wasn't open. Then as we went and disreefed to be the fully open position, a second chute appeared to have some damage. It was still pretty much intact, but part of it seemed like, again, more of the riser lines or suspension lines seemed to get fouled or cut, and so part of the parachute was not inflated. So we had one good one, one completely failed one, and then there was a parachute, and then the one was probably about halfway. So so that caused the booster to hit the water at a higher speed than expected. So it was a pretty hard impact, and because we think because this one parachute was partially inflated, we got a little more horizontal velocity of the parachute than nominal. So you had a hard vertical impact and a vertical velocity and a horizontal velocity. What that caused is a hard impact, and then the vehicle slapped down. The booster slapped down pretty hard in the water. So that caused some damage on the booster, and I'll go through kind of what we know. Talking to the first stage guys last night, the damage we've seen, which we'll go through, is analogous, if not very similar to what they've seen on other shuttle flights when they've had parachute problems. So no one is concerned about it. In fact, the parachute guys were ecstatic, was their words, as to the data and the information they got from this flight. They really wanted to test this out. A couple of things about the Ares 1X compared to Ares 1 is 1X empty is about 15% heavier than Ares 1 empty. And that's because of the fifth segment simulator. Our dummy simulator is full of electronics and avionics, and we also added a bunch of ballast in the back end of it to make it more stable because of that. So this was an over-test of the Ares 1 chutes. Again, there's 15% more weight that it had to carry than it would for Ares 1, and so therefore there's a whole lot more load on the chutes than it would have been. Again, but this was a test to figure it out. That's why we did this test, to see how everything would work. We'll get more data from the data recorder as far as the chute dynamics, and we have a separate electronic package on board to measure the dynamics of the booster during this whole separation and reentry approach, which we'll hopefully get out of the vehicle again in the next few days and start looking at it. So a lot more data to come on that. So as far as the booster damage, there is a dent in the side of the booster. That's really in one of the motor segments. It wasn't from impact or anything. It was from essentially looks like the buckling. It hit so hard that it buckled, and from the water impact. So all the damage we saw in the booster was due to the water impact portion of it. The booster is still in the water. It was towed to Hangar AF this morning, and it's being assessed. So we saw a dent in the side of it. There's a very top joint between the 5-segment simulator and the top of the forward segment of the booster. That joint appears to have opened up during the water impact. So right now, just to make sure there's no other damage, the team is inspecting the booster all the way around while it's in the water to make sure when they do the lift that there's no safety issues for the people around it. They have a process in place, and hopefully within the next couple hours they'll have it out of the water. But they're taking their time on this one just because it's longer than they've ever done before. It's heavier than they've ever done before. This is a little different than a shuttle booster now. It is a superb test for the Ares 1 approach. But just to be safe, they're taking their time, and we hope later tonight to have that booster, later this afternoon, have that booster out of the water. And I think I said up front, the data recorder will try and get out sometime tomorrow. And pretty much completes what I had written down as far as that. So for the damage in the booster, I probably tripped over that a little bit. There was the parachute part itself, and then when the booster hit, there was this gap that opened between the 5-segment simulator and the top of the forward segment. There was a dent. I'm trying to remember exactly what segment it was, and my mind's going blank right now, unless Amber happens to remember. Yeah, it was aft. It was either aft. It was aft center. Okay, and it was aft something. So that makes sense. So the aft center segment had this dent in it, which appears to be more of an impact buckling load effect. And then in the aft skirt itself, we've only seen some underwater pictures, so we need to see them for real when we get it out of the water. Because it hit tail first, there was some damage to the actuators themselves of the thrust vector control system. It's tough to say how big of a damage it really is, but again, that was within family. There's been plenty of other shuttle flights that had similar problems, so we don't really consider that all that significant. But once we get the vehicle out of the booster out of the water and look through it, and by Monday or Tuesday next week, we'll have a much more specific list for you guys as to what things. But the point is, no one's worried about this. This is not a concern. This is part of the test, and we'll just go. This is just kind of normal post-flight analysis. We're going to go through and take our time going through it. The team's not working the weekend or trying to resolve any of these things anytime soon. This was just part of doing the test, and we'll just matter of factly go through the data. So the team is still very elated. I think I mentioned the parachute guys are ecstatic at this data, and the fact that they got something interesting to go work, it makes them kind of happy to go figure out what happened with the parachutes. And the damage was just all collateral because of the parachutes. So really, we're not really dwelling on the damage. It really isn't all that interesting. We never plan on using this booster again or this TVC again. But those are all a direct result of the parachutes. So the emphasis will be on looking at the parachutes. But again, we don't consider this a significant event. It just the reason we did the test, it was one of our objectives to do the separation and the parachute testing. So that pretty much covers what I had written down, and got time for questions. Bill?
Well, a couple from me. This was 15% heavier empty than an Ares 1, obviously, and you guys tested chutes before this mission. What did you test to? And in other words, were you testing to Ares 1 loads or Ares 1X impact loads or deploy loads? And do you have any numbers for that impact? I mean, I think somebody said before launch a normal hit the water was like 24 Gs. I think that number's in my head for some reason. I don't know if you had any actual numbers.
I don't, although I'm sure someone does. And once we look over the weekend, we'll be able to figure that out pretty better. So I think we have another event sometime early next week, and by then I can give you some numbers as far as the impacts themselves. For the first question, as far as the parachutes, these are the first time these parachutes were tested, 3 together in a cluster at the dynamic pressure range and the separation range that we expected, and the altitude, more importantly, at the altitude that we saw. So just because of the limitations of aircraft and aircraft size, we couldn't do 3 at the altitude that we'd see for this booster. So you could do 1 high up or 3. So this was the first time test that they've seen, and the test was an Ares 1 test. So it was a little bit lighter than we'd seen for that one. But again, this is the first time we had 3 come up at the altitude that you see. And altitude is, of course, important. The higher you are, the faster you'll start to decelerate. And so this was unique.
And just one more from me. It sounds like from what you're saying, the only anomaly of any significance was the chute problem. And I guess I'd just ask you, based on quick look data on a scale of 1 to 10, where you think this thing came in as an overall test flight.
Oh, as far as success, you mean? Oh, 10, without a doubt. I mean, without a doubt. The fact that it didn't work is not a problem. You've heard me say that over and over again. We want to find these things that aren't quite working the way we are. Again, this was an overtest for Ares 1, as far as the heavier booster part of it, and the heavier dynamic pressure at separation. Remember, we were at 100 pounds per square foot, and Ares 1 somewhere around 10 or 15 pounds per square foot. So everything was extreme relative to Ares 1. So the fact that we had these little problems with parachutes, and one didn't work and one partially involved, does not at all in any way detract from the success of the flight. In fact, it makes it even more successful to the parachute guys. They're happy to go find something to go work.
Todd Halverson of Florida Today. I was kind of impressed with the video of the first stage controllability. Things seem to be pretty rock solid. Did you see any significant roll at all?
No, and you're exactly right. And rock solid is the words that we used. I mean, it was it sounds boring, but it was exactly like the simulation said it should be. In fact, our simulation showed a whole lot worse when we put in dispersions. So from the time that we cleared the tower and we did our 90-degree roll maneuver, we saw very few oscillations. I think it said on Wednesday, we had basically 3 big pairs of firings to keep the roll under control, which was, we typically would see 20 or 25 in our simulations. So we didn't see any evidence of roll torque or roll dispersions. As far as the nozzles themselves and the inputs to keep the vehicle stable, they're very, very small. They're in a tenth of a degree of nozzle deflection to keep the vehicle stable. Also, on top of this, remember we put in these 3 different program test inputs, these PTIs, at various times during the flight, and like 34 seconds, 55 seconds, and 75 seconds when we put them in, and they were a couple tenths of a degree, 0.1 degree, 0.3, 0.4 degree, and you could see him in the data because there was nothing else happening during the rest of the vehicle. So that was, so yeah, it performed great. Our GNC guys and the Ares side did superb making this algorithm. Again, this is the Ares 1 flight control algorithm, not Ares 1X, but Ares 1 that we flew. So great confidence that they found a way to handle all the winds, and this long, skinny vehicle was not a problem for it.
And just to follow up on your comments on thrust oscillation, what does this say about how the thrust oscillation levels would be on a 5-segment solid rocket booster?
Yeah, you know, the difference between a 4-segment and a 5-second is more the frequency by which it occurs, and so we're at shuttle numbers and shuttle frequencies, and in a clearer moment I could tell you off the top of my head what those are, but right now it eludes me, the difference in frequencies. But because they were so low in magnitude, you may expect a different frequency for a 5-segment, but I think it's a good indication we'll also see a reduced magnitude as well from some of the predictions that we've heard. You know, a year ago it was kind of doom and gloom for thrust oscillation, and then we instrumented the shuttle flights. We've done these ground tests, and now we've done this test, so we're just not seeing these numbers in thrust oscillation. Now, to be fair, we'll take the thrust oscillation numbers we do get once we get the data recorder back, which is really high sample rate, you know, thousands of samples per second, and we'll compare that with the strain gauges and accelerometers in the vehicle, and we'll line those up on top of each other and see if there's a spike in a pressure, if you saw a corresponding spike in the vehicle. So that's basically the forcing function and the response overlaid. And that'll probably take several weeks or so for us to go do. Once we get that, we can come back and show you guys, here's what we did and didn't see as far as thrust oscillation. But more importantly, it's the impact on the vehicle that you care about. All boosters have some kind of thrust oscillation. We don't care about that. What we care about does it impact the vehicle. And so far we haven't seen that, but we'll have to, you know, convince ourselves and show you guys the data in the next few weeks.
Marcia Dunn, AP. For the 2 parachutes that had trouble, I couldn't follow where the trouble occurred, like partial opening, full opening, all this business. So can you just go through that simply one more time without using the word reef and all that business?
I'll try not to, though. It's an important part of the story, so I'll try and use some synonyms.
Step 1 and step 2.
All right, so there's a whole sequence because there's 5 chutes involved in the sequence. So there's a pilot chute that comes out first, it pulls out the drogue chute, pulls off the forward skirt extension, all that was cool. And then the 3 parachutes, 3 mains came out, and they partially deployed. Partially sounds like as they should. You say partially makes it sound like it should have. So all 3 came out as expected in basically a 50% opening condition. And that was what they're supposed to do. You want that. It's a good thing. And then, so all the chutes were good. Then a couple seconds after all 3 were in this 50% opening position, one of them failed. You saw the lines go slack, and it basically became a streamer. Yeah. So one deflated. So it provided no deceleration, capability at that point. So we had 2. So 2 were working fine. And then when we get to the plan point where you go from the 50% opening part to the fully opening part, another one of them, partial, maybe a third of it or so, it seemed like those lines went slack and caused the part of that canopy to flip open. So most of it was round, but the part of it just kind of flipped open. So you had about half of the acceleration capability than you would have. So it probably came down on 1.5 chutes as opposed to 3. Is probably one way to think of it.
Okay, so it never did get to the full position.
As it opened up, this happened. So it opened up and happened. Whether it was related or a coincidence, we can't tell at this point.
So instead of being like a nice little thing, it was just sort of half tilted.
Yeah, half was a nice little thing. The other half was open.
And you're not sure why?
We're not sure why. That kind of thing is more indicative of the riser lines themselves failing as opposed to the parachute material. But we'll have to get the chutes back and then go look at them.
Oh, could I just ask, too, with the damage that you took on the booster, were any of some 700 sensors damaged because of that, too, and you might not get as much data as you had anticipated?
It's all water impact, so we don't care.
Okay.
At that point, the sensors did their useful part of it.
Okay, there's nothing you need to
Almost
look
all
at.
the sensors were for the ascent port of the flight.
Right.
A handful were actually for the reentry part of it. But when you get at the water impact or the parachute deploy, there's no more information from the sensors. Those are all done.
Bobby Black from the Orlando Sentinel. 2 questions for me. One was about the flame walkover that you expected. I mean, impacting some part of it, but not the upper part of it. What does that mean for the Ares 1? I mean, does that fall what you expect? Because I know that flame walkover was also a concern on.
Yeah, good question. And we probably didn't do a good job explaining the reason for the flyway maneuver. When we first put this vehicle, and we knew we were going to fly it from, we really concentrated on physical clearances, making sure you physically don't hit anything. And then as we thought more about it, realizing that this is a shuttle pad with a 1X, and so it wasn't quite made for this vehicle, nor was it altered or modified or hardened. And so then we decided we better keep the plume away from most of the structure. So we added the flyaway maneuver about a year ago to actually fly it away from the FSS. In doing that, the only way you can do that is to basically fly it away, and then at some point the flame is pointing directly, at the stack itself, at the FSS itself. So that's different than shuttle, and therefore the areas in the shuttle that were hardened to protect it from the plume were different than we would need. So for an Ares 1, which can have a different MLP and a different FSS, it doesn't quite apply. It just kind of a statement of the obvious. If you're going to plume something, make sure you've hardened it first. Since this FSS and MLP is not going to be used for shuttle anymore, or for Constellation, this was like a one-time use. So we didn't spend money to go and harden it.
So it confirms what you would have to harden when you developed all the launch infrastructure.
In a general sense, the fixed service structure for Ares 1 will be different, and so it's more in the area that kind of a MLP-based area. Wherever you do for Ares 1, that part needs to be hardened, but the specifics are different because the MLP is going to be different configuration.
Okay, and then I had a thrust oscillation question to follow on to Todd's, and that is, I'm a little confused. Maybe you can explain. I thought that part of the problem with thrust oscillation is it's not every motor that shows it. And so it's like 1 in 10, I remember a figure reading. And then the other thing that I'm a little bit confused about is I understand what's really important is the entire frequency of the vehicle. So even if it's low, I mean, it's not as strong as you expected, but it happens to be in the frequency of the stack. That's what the problem is.
Yeah, great question, Jim, and you got it right. So to some degree, there is an oscillation built into the motor, in all motors. The question is 1 out of 10. Some of them have much bigger, more pronounced values than others, or magnitudes. And there's just a couple in the shuttle fleet that show bigger values than the other. And so we're covering all of those just to be safe, as far as we being in the Constellation program in Ares. But when we actually look at motors and Ferraris and for test data, we're not seeing those quote outliers, those ones that are really driving the overall part. And so we're trying to get more data to see whether that was an anomalous motor or something unique about it, or we need to protect, because someday we'll see that again. So that's why this test itself is important. Kind of for the reasons of your second question, we know we're going to get some of that. The question is, can we measure it in any appreciable way? And so far, it doesn't seem like it's really that significant from a magnitude. But more importantly is will it tune up to the vehicle frequency? And the vehicle frequency for our vehicle is similar to Ares 1 purposely. It's not exact. We're a little stiffer, so we have a higher fundamental frequency. But that is the mode that we're trying to capture. Is given what we have, does it compare to Ares 1 to fly it? What we're trying to do for 1X is does it match our models? And given we think it's a force, we have a force segment and we think we know what the magnitudes are, does it match what we predict? And so far we're seeing it's a lot less than we've seen.
To make sure I understand, the test was geared to see if the oscillations that did take place hit the frequency of 1X.
Well,
1X is a little bit stiffer than.
Yeah, I can't say we plan it purposely because those things kind of fall out. So the vehicle was built to be as close as we could to Ares 1, and that's what it was. And the thrust oscillation, kind of is what it is in the booster. So we didn't do anything to try and make those close to each other or far away from each other. And we did look at it just to make sure that there was any concerns. And even with the thrust oscillation magnitudes people were talking about, we still didn't see a particular issue with our vehicle. But we still wanted to measure thrust oscillation just from a data gathering event. And that's why we got it.
Hey, Bob. Greg Pallone, News 13. You had mentioned before that you don't want everything to go right. Do you feel like, in a way, that perhaps too much went right to where you won't learn, or do you almost wish that you had more issues with this so that you could kind of glean from that?
Interesting to try and put that in words. It was a great flight, and the parachute thing is a very, very minor thing. In fact, again, we're not really dwelling upon it. Just something we'll go look at. We have a few years to go look more into it. So that's a very minor aspect. People like to dwell on things that aren't perfect, but like you said, as an engineer, everything goes right. You pat yourself on the back and say that went great. When something is a little different, that's exciting. All right, there's something to go look and change and improve. So everything went really, really well. In fact, everything flew just right down the middle of the pipe, and but everyone's just pretty still ecstatic. It just showed that we got our miles right in all areas. The ascent part of it, the GNC part of it, all is the flexible body interaction. All it's really hard stuff to go do, and so no, no one said we didn't have any more problems. But the key is we haven't got yet to the 700 plus sensors. That's still work in front of us. There's no right or wrong, good or bad with those. That's just data that we collect. So there's a lot in front of us to go look at. So the engineers will be busy for a long time. So no, nothing but pride from the team that it went as well as it did.
Kevin Oliver, WFTV. On the separation on the video, it looked like it bended, or there was that bend in there. Are you saying that if there was a second stage, that the engines would have kicked in and that wouldn't have kind of?
When we say
curved?
bend, I think you mean it was a rotation, or
Right.
Yeah, the second stage for Aries has a separate attitude control motor, and so its whole job is to keep it pointed in the right direction. We don't have one of those for our upper stage, and the aerodynamics of the upper stage, along with the mass properties of the upper stage, dictate that in most cases it's going to tumble. So it did exactly what it should have done. I poorly communicated that on Wednesday, but my team was nice enough to remind me about it soon after. And again, we have hundreds, if not thousands, of simulations showing that very same event. That the upper stage is unstable. So as soon as it's separated from any kind of active control, it starts to tumble. It can't help itself. And the first stage tumbled because we told it to. We had those booster tumble motors that fired after 3-second separation, and it tumbled. So it all worked out exactly as it was supposed to. And when we get more videos out to you guys next week, you'll be able to see what we're talking about and how it looks good.
Stephen Young with SpaceflightNow.com. I'm wondering if there was a moment when you received the first word from the chase planes or the ships that maybe the parachutes weren't working as planned, that you felt maybe the booster would sink and you'd lose the data, and how did it feel when you discovered that even with on half parachute power, you managed to still be bobbing up and down in the ocean?
Yeah, actually the way it played out was the opposite. The first call we got back was from the recovery ship saying they see the booster bobbing in the water. And so that was great. It was only after the fact that people started getting the videos back and saying, hey, there's some indication that we had a parachute problem. So because the first call was we see the booster and it's floating like it's supposed to, we had no concern about that. And afterwards, when we saw the parachutes, we assumed properly that it must have hit harder than expected. But again, damage to the booster is not really a concern for us. It's not part of our criteria. It's not part of our success. We don't plan on reusing this at all. So it doesn't really matter to us what happened to the booster. What happened is that we got the data and get a good test of the parachutes.
And are we going to see the video from the chase plane and the ship?
Yeah, not today. We're working on getting it released sometime next week as soon as we can. I try to describe all the things that you'll see when you see it, so it won't be any surprises of what you see. But we're still working to get that released as soon as possible.
Was it quite a splash?
No. It really wasn't. It wasn't like someone doing a cannonball in the pool. You saw it coming down and the tail hit and then it fell forward. And the other part I forgot to mention is that, which is really neat, is that the forward skirt extension, the part where the joke chute was on, that stayed in frame, and you could see it. And when the booster hit and went horizontal, then you saw the forward skirt extension come down on its drogue and hit, fairly close to it, was as expected. And then it sunk.
Just one more from me, following Bobby's question on thrust oscillation. On those outliers you guys see that are really above what you've seen on recent boosters, were those guys from very early in the program, and those horizontal test firings? And Hanley was saying that the thinking was that might be related to the way the things were fired on the ground versus an actual issue that was something to be concerned about.
And I'm not the right person, Bill, to go into detail about it, unfortunately. But what Jeff said is true. That there's, I think, a ground test and maybe a flight that indicates that that's really driving it. But they were a while ago. Yeah. And but again, when we have data like that, you just can't throw it away without a good reason. So we kept it, and that gives a big dispersion band. But what we see day to day or test to test is much smaller, and we confirmed that, I think, in our flight a couple days ago.
I just wanted to ask, so do you think by looking at the parachutes, you're going to be really able to tell what happened? I mean,
yes, absolutely. If it was something to do with the separation event and there was scorching, that gives you one indication. We don't think it's the case. If it's just the rise lines were overstressed, you can tell by looking at that. If it was the actual ribbon material in the parachute, you can tell that.
Okay.
So right now, with the way the sequence works, the parachute guys probably won't get a chance to see him until Monday or Tuesday. So hopefully later in next week, we'll have a good feel as to what we think the failure scenario was.
Okay.
But again, don't play this too much. The parachute thing was like, hey, look at that. And we're not worried about it. There's no investigation. There's no unusual thing we're doing. We're just going through our normal post-test. And unlike a shuttle flight where something may happen and everyone scrambles to kind of give you all the answers, my team has the weekend off. My team has every weekend off from now on. We're not rushing through this. We have plenty of time. So data will come out. When it comes out, we'll give you a little more info next week and a little more the week after that and a little more the week after that. but there's no accelerated approach to go address this because there's nothing that we found that was any issue that affected shuttle or Atlas or any other program. So we're just going to take our time and go through our normal post-test work.